more on the merchant fleet. So we follow roughly 115,000 vessels worldwide. We are collecting positioning data of all those vessels here at EMSA in a huge data center. So we collect more or less 45 million positions per day using AIS, probably you heard about it, the automatic identification system, but also LRIT information, long-range identification and tracking, VMS, the vessel management system of fishing vessels, which is also important. And also we have quite an extensive satellite program. And also the satellite program for your project is also important. I will come back to that a little bit later. From a governmental perspective, we need to understand what's happening at sea because we also need to intervene or to guide. For example, around Europe, we have a lot of vessel traffic separation schemes. So when there are narrow straits in Europe, the ships, like traffic on the road, they have to follow their own lane. And also to avoid collisions between vessels. And the governments need to make sure that the shipping is behaving in those corridors, in those lanes. So there's also one of the ways we are also following what's happening at sea. Of course, there are many unexpected events, like you also studying or did study in your project, like vessels that start to be dangerous to the surroundings, or having floating containers, or having whales. So what we also developed are algorithms to understand better, let's say, unusual behavior of vessels. During the last years, we have developed more than 24 of them, and some of them I think are directly relevant for your project. One is about lack of reporting, which is immediately a danger to shipping, to navigation, if big ships are not reporting anymore their position. But also drifting. You can imagine if, for whatever reason, a ship has an engine failure, and the crew is not able to manage anymore the vessel, then of course the vessel starts to drift. And it's also good to recognize early that a ship starts to drift. And this is also one of our ABMs that we have. These algorithms are needed because sometimes we have not enough information of what is happening at sea, certainly when it comes to whales and containers, I fully agree. But sometimes we also have too much information, and then we need also, let's say, the computer to help us to digest and to take out the information that is really relevant for the operator or for whatever responsibility the operator has. So in that sense, also at EMSA, we try to guide also, let's say, this selection of information that is most relevant depending on the role that you have for what is happening at sea. Then, of course, the support to search and rescue is also one of our tasks as well with all our information tools. And that is, I think, also interest of you. When we go one step lower, where EMSA is more indirectly involved and we look at the vessel, of course, when it comes to safety of navigation, we need to have a look at the communication equipment on board of the ship. And I think we made a lot of progress in developing really state-of-the-art equipment on board of the vessel. But also other equipment is relevant, like the engine, the rudders, that they are functioning. And of course, EMSA in very different ways contributes to those fields as well. When it comes to, you call it operator, we talk more about the crew. The crew, we also follow, not persons in detail, of course, but in general, the training of crew, because certainly in Europe, I think also on vessels sailing around Europe, we have a lot of third country crews, and we want to be assured that those crew members have the right education and training to operate the ship safely, but again, contributes to safety of navigation. And also the watchkeeping, the living conditions on board, the discipline on board is very relevant, and I will come back to that a bit later. A third element for the vessel directly is the weather, because in stormy weathers we have more groundings and collisions than with nice weather. So the seaworthiness of a ship is very important. We do a lot about the seaworthiness of vessels, but I think it goes a bit beyond today's meeting to go into the detail, but that's very important for us. And also in the maritime picture, we combine mid-ocean data. So wave current information is also very much relevant for safety of navigation. When it comes to accidents, and my colleague Enrico will be, I think, in your first panel, we are collecting accident investigation reports done by the accident investigation bodies of member states. We put them all in a big database, and we also analyze what has happened, to analyze, to draw recommendations, not to blame, but to understand how the safety on board the vessels can be further improved. And also safety of navigation has been one of the thematic reports done by EMSA, and I think Enrico can also further tell you about it. Of course, what is interesting is that all the technology on the one hand is helping us to have safer navigation, but also requires higher skills of the crew. So technology also represents complexity. And if you are not well versed with the equipment that you need to handle, it can even turn into a safety risk. So I think that step by step, the seafarer profession becomes a more high-tech job. And I think it also deserves a better perception with everybody, and also a better evaluation to see that more and more seafarers need to have a high technical knowledge to be very functional also on the bridge, which is very important. An interesting aspect.
Actually, of course, it's not very much in our remit, but it's not completely unknown to us because we are also operating drones in support of member states. And one of our drone projects is in support of the Italian Coast Guard that works together with a research project to look at whales and dolphins in the West Med. So with drones, also the patterns and the species are being watched, also for safety of navigation, but also for the, let's say, protecting the marine environment. I saw also upstairs that also satellites can be used. Yes, satellites can be used to detect whales and also floating containers, but it is rather difficult because you need to have a very high resolution satellite image, and a high resolution image only covers a very small area. So only if you have a kind of indication that there are whales in a particular location or that there was a sighting of floating containers, then I think satellites can be used to further observe the area and to find whales or containers. If out of the blue you want to scan the ocean, I think you need to be a billionaire to finance that. And I think it's not very, very efficient. So I think for these type of objects, it is indeed rather difficult to have a very reliable system and predictive system where containers are. In our Safe CMAP system, one of the systems that we operate with and for member states, we have the possibility for crew to report floating containers, for example, which can be very useful, but unfortunately, it's not always used to the extent that we would like it to be. It's not always given the importance. And of course, certainly for pleasure craft, it is very important to know, because it's really a direct danger for them if you hit on a floating container. So I see a lot of commonalities between your project and EMSA, so I'm very happy that you are here today. No challenges, maybe some thoughts for your next project, I don't know. Of course, with climate change, with the poles that we have more melting ice. Melting ice leads to ice plates breaking off, leads to more icebergs at sea, which also pose a navigational danger. Then we are talking about the Northeastern Passage, so going from Europe to Asia via the north coast of Russia, which will also be used more and more in the future, which again will add another complexity to safety of navigation. And also unmanned or uncrewed vessels. We also studied that a lot. Once the technology is quite advanced, the regulatory side is a bit lagging behind. But if you have, of course, uncrewed vessels also participating in normal traffic, there is another challenge to meet how to do that safely if you have hybrid manned and unmanned vessels at the same time, at the same place, operating at sea. So in that sense, it's also good that the agenda is not empty for the future and that there are still many challenges. So I hope you will have a very productive day, and congratulations already with all the work that you have been doing. And I hope that this work will also continue in the future, because the seas are never safe enough and we can always do better with safety of navigation. Thanks a lot and have a good day.
Thank you so much. Please stay on for a while. I heard a lot of touch points between EMSA and the project, and I also heard that I think we are very much on the same page and are singing from the same sheet. I also noted your concern for the future, and I think this is really interesting. And the safety of the future is not less challenging than the safety of aviation today.
True.
So that is going to be really, really interesting. I would also like to take the opportunity to thank EMSA as a body for permitting us to be here. I am sort of extremely proud, but also very humble, and I think that this is something we have been hoping that we could achieve. Visiting you and exchanging ideas and knowledge and so on and so forth. So thank you very much for that.
It's a great pleasure.
I would also like to mention the organizing team, and I see Bettina is here, so maybe you would like to come up here and be given an official thank you.
She made it all happen.
She made it all happen. And what you will find in the back is
It's not fair. I'm just organizing and I get the present.
what you are finding in the back is a USB hub, which has a lot of connections, and this is because the Ocean Project is a lot about connectivity and it's about sharing data. And this is what this device will do for you. For you, I have something, a little bit of a rarity, and I've been asked by the Nordic Institute and by Lloyd's Register to give you the alert compendium, which is a print of all alerts from 2003 to 2016. So please, thank you so much
To be even more worried.
to be even more worried, or to get the recipe for what can be done.
Closing off it, man. Until I was fancy. Thank you.
Thank you. Thank you so much.
Good day.
Now, now to what this project is all about. And without further procrastination, then this is why we're here. These are the representatives of the seafarers, or more precisely about the watchkeepers on the bridges of our ships. They are at the core of the Ocean Project. They are at the core of the way we think. And we have tried to understand how they're doing things in order to help them become even better than they already are. I think if there was only one common denominator in the entire project, this is it. This is the passion for being human-centered, for embedding the understanding of human needs into everything we do, whether it is bridge instruments or ship design or the design of operational procedures. It's all about being human-centered, and this is what I pride myself about, that we are in the Ocean project. As I have said earlier, and some of you may have heard it before, then Ocean is not just the name, it is also an acronym, and it is short for Operator-Centered Enhancement of Awareness in Navigation. This is exactly like what Mr. Ward was saying just a little while ago. This is what we bring to the table. This is an awareness in order to reduce the amount of accidents and incidents that there might be. So it's also, in a way, our mission. We will try to keep that focus during the day. And our claim is that with Ocean, with the adoption of the things we have been doing and we have been disseminating, navigational safety is even safer. And that brings me to reminding all of you what Ocean was really about. So this is a video that we produced 3 years ago when we started on the project, and it tells about what we thought we would do. And then later on, we can discuss whether we really did it. So please run the first video.
It is easy to forget that at any given moment, there are hundreds of thousands of vessels crisscrossing our oceans. The numbers are just massive. A staggering amount of vessels, people, and ports are involved. In spite of its great complexity and the huge number of vessels, the industry has an excellent safety record. That's because seafarers are incredibly capable and rigorously trained. But accidents do happen. Accidents happen not because seafarers are not good at what they do, but because, for a plethora of underlying reasons, they either don't realize there's a risk or they can't avoid it. Ships occasionally collide with other ships, with fixed structures, or run aground. Containers might fall off ships and remain floating, causing risk. And unfortunately, vessels have hit whales, particularly near migration routes. But what if navigational passages could be made even safer by greatly improving the situational awareness of those handling the ships? That is precisely why the European Union and the United Kingdom have decided to fund the Ocean project. We believe that successful watchstanding happens when humans, technology, and organizational matters like training, procedures, and rules and regulations work in unison. Our aim is to support mariners through equipment that is designed to more directly support human needs. This will increase their capabilities by improving their situational awareness and evasive maneuvering capacity, rather than by increasing the autonomy of the vessel itself. Open, voluntary, and free sharing of information is at the core of Ocean, because we want to enable the seafaring community to help each other to make even better decisions. This is how it'll work. Say there's a hazard, maybe a floating container or a pod of whales crossing a waterway. The hazard will be spotted by either a person who reports it via our Ocean reporting app, or it could be detected by a satellite, seasonal forecasts for marine mammal migrations, or even hydrophones listening for cetaceans. The information would be almost instantly transmitted to a database on shore, which would communicate that to all types of vessels using tools that already exist on their bridges. The Ocean project will also model the drifting of floating hazards and the movement of marine mammals, so the reporting will happen in near real time, which is crucial to build trust and compel seafarers to take immediate action. Parallel to this, the Ocean project will develop the Ocean 4D Situation Awareness Display, which will provide an integrated, designed for the purpose, uncluttered, and focused presentation of near-field threats and navigational hindrances. The Ocean project will suggest the creation of a European navigational hazard infrastructure to collect, process, and distribute data relating to the presence of marine mammals, floating containers, and other dynamic navigation hazards. Ocean's Evasive Manoeuvring Agent, or EMA, will be an improved manoeuvring tool working in tandem with existing ship systems, continuously assessing navigational safety. These tools will mostly be open source solutions, free of charge, and subject to voluntary adoption. This project is pulling together a wide community of stakeholders to create powerful and effective solutions. Ocean might not single-handedly solve the challenges that seafarers face daily, but it will definitely be a valuable step towards the solution. Keep Ocean on your radar and subscribe to our mailing list.
So this is what we set out to do 3 years ago, and I think today is the day where we decide whether we did it or not, and that is very much up to you. We would really like a dialogue around this. I think back to the keynote speech, and I see so much commonality between what EMSA is doing and what we were doing in the project. So there should be a basis for good dialogue. There's definitely basis for qualified feedback. We would like this event to be a kind of a knowledge sharing event. We would like to look into possible synergies. We would like to, if we can, maybe even get a common understanding of what's next. I mean, how are we going to promote this? How are we going to proceed? How are we going to continue to have an impact on maritime safety, the way we are thinking alike and put work alike. To bring that out, the nice questions are the simple questions. We would rather like the complicated questions, the challenging questions, the critical questions, and they are very, very welcome, and they are also invited. Don't hesitate. And the way we're going to do it is that there will be the option of putting questions to the panel discussions that we will be having during the day, either from the floor or from a simulcast in London. It is so that part of the panels will be broadcast to the ENHI headquarters in London, and there is, I believe, a full room of 40 people, and so they will be with us occasionally. And then, of course, we have an online presence. This is a hybrid event. And for those who are online, you should be able to see something like this on your interface. And that means that you can write a question and you can send it to us, and we will deal with them to the extent that we have time. And I would like to promise that if we don't have time for those questions, we will revert to you later. We will figure out who is the best person in the Ocean Consortium to answer it, and you will get an answer. So don't hesitate. Just bombard us, please, with questions. This is what we hope, and this is really why we're here. In case you need contact addresses, they are there. I will leave them on just for a little while. But you should also have them on the invites for today's event, and so on and so forth. The next thing is that the Ocean Project is a quite complicated thing. There are very many activities, and they are multidisciplinary. They are looking here and there, but they are all joining up. And we'll try to make a kind of an infogram that starts where we want to start, with the bridge and the teams on the bridge and the watchstanders. And we believe that the Ocean Project is having an impact on these things. So we are doing something about collision avoidance. We are doing something about decision support, etc. But that doesn't come out of the blue. And so these improvements that we could call the speech bubbles in the wheelhouse, or what we hope that people are talking about in the wheelhouse, or imagining that people are talking about in the wheelhouse, they come from a large number of underlying knowledge, from underlying decisions, from underlying enablers, as I've chosen to call them here. And what is interesting is that time plays an enormous role. If you believe or consider an upcoming situation, I would like to call it, in watchkeeping, how that pans out, how that goes, is depending on a huge chain of decisions and events and influences and contributors that happens in the past. So the point is that you cannot do anything about the present unless you understand the past and how it has influenced a current situation. So this is how we think about really improving maritime safety. That you have to go back. You have to look at the past. You have to look at the decisions. You have to look at how the ship is designed. How are the instruments designed? Who decided to purchase them? What are the operating procedures? What is the level of training? What is the working climate on board? What is the leadership style? And all of that stacks up to the way a particular watchkeeper will be reacting in a particular situation. So if we really want to improve maritime safety, we need to go back and have a look at these things and start the improvements in due course. I also realize that this is hard to read. And I also realize that there are very many components, and they can be difficult to keep a track of unless you are very familiar with the project. So this slide that we call the infographic is available also in print, and it is upstairs. And you should grab a copy, because that will make it a lot easier to follow what we are going to do going forward today. But we are also trying to help. So we will highlight the particular subjects that we are talking about, and we will introduce the topic. So I will read aloud what it says on the arrows, so we know what is happening here. Good. And that brings us to the first panel that we have. So I would very much like the panelists to join me up here. Do we have a certain captain from London with us? I hope. Good. Let's not wait. The first thing we're going to talk about today is this foundation, all the arrows on the lower side of the infogram. And with me to do that, I have a panel. First and foremost, Professor Margaretha Lutstoft, who is a former captain, a professor of maritime studies and maritime human factors at the HVL in the University of Western Norway. I hope to have Ali with me. Ali is a captain. He is a technical manager. I have Ali with me. That's amazing. Thank you very much. So Ali is the captain. He is the senior technical coordinator in the Nautical Institute. And he would be joining us for this panel. And later on, he will host the simulcast event that we have in London. Then I have Captain David Patrato, who is sitting here on the panel. David is the Chief Technical Officer or Head of Projects at the Nautical Institute. I have Enrico with me. I see. Yes, good. And Enrico works for EMSA, is leading work on accident investigation. And as a background, I was impressed to see a double master's degree, a master's degree in economics and a master's degree in science, which is not a small feat. So thank you to you, Enrico. We have Sani, who is sitting here. Sani has a PhD in psychology and is a researcher at the Western Norway University, where I also work. And Odie, we have sitting there. Odie is a researcher with the National Technical University of Athens, has an engineering background, and by the way, is a regional famous musician, I'm told. And finally, we have Jonathan Ursey, who is the human factors lead in the technical directorate of Lloyd's Register and works from the UK. So this is the panel. So let's start somewhere. And the first thing we're going to talk about is situation awareness as a concept and naturalistic decision making. And what we try to show on the slide here is that this has a bearing on the situation awareness in the wheelhouse, a direct bearing. So a question to Margareta: can you give us a quick rundown of situation awareness and realizing that naturalistic decision making is predominant in some situation? Can you explain a little bit around that?
Yes, I'll certainly do my very best. And first, I invite you all to think about what is it like to be on a ship's bridge. We're on watch together. Maybe not all of us now. We have to manage incomplete, ambiguous, and changing information. We have competing goals, time constraints, and high stakes. And situation awareness is a way of describing how humans make sense of and respond to situations. A simplified way of explaining it is that we have an understanding of the state of the world we're in here and now. This understanding is continually updated. And this updating takes place in 5 steps. 3 of them are situation awareness, and 2 of them are about what happens after when you're responding to this image. First step is perception. It's when we pick up data and information from the world around us. The second step is the comprehension step, where we interpret and transform this data into meaningful information that we can use. The third step is when we project this understanding into the future to support decision-making. And the fourth step is decision-making, and I'm going to make a slight detour out of the situation awareness here. Traditionally, decision-making has been described as a logical and normative process, in a way assuming that humans are like computers. We have all the time in the world and all the information possibly available to us, and obviously that's an impossible task. As I mentioned in the beginning, the world is not simple like this. We're using another approach in this project called naturalistic decision-making, which describes how humans make decisions in the real world, especially in constrained situations. Basically, this is about pattern matching. You remember a similar situation you've been in? How did you act at that time? And then you adapt the strategy you use to the current situation awareness you have. So you're not starting from zero every time. You always base your decisions on something you've experienced before. And coming back to the updating of the understanding of the world, we have now perceived, comprehended, projected, and made a reasonable, but perhaps not perfect decision. It's time to act. And the fifth step, action, obviously has an effect on the situation we're in. It addresses whatever we decided was necessary. For example, we're changing course to avoid a hazard. But it also changes the state of the environment, and the continual updating of the understanding we have, it continues. And I'd like to point you towards what we call Ali's videos, which are on the Nautical Institute website, where we have, he has made a lot of educational and training videos on some of these topics.
Thank you so much. Thank you so much. That is interesting. And I think especially the issue that decision-making in practice differs from what is in many textbooks is a realization that we are bringing forward. So it influences design in a different way than the sort of the normative decision-making that is the way that is usually described. So thank you very much. But that takes me on to the next question, and this is about usability and human-centered design. And I would like to ask Sani to share something about that, please.
Yes, I can start to say that it was a joy. It was a joy to work in a multidisciplinary team together. You don't often do that. You stay in your profession, and but in this project we worked together as a team. And what I would like to share with you is that the main takeaway is that human-centered design does not add complexity. It reduces the risk and cost of getting design wrong. By focusing on the needs, behaviors, and experience of people, human-centered design, designing for people, with people. It means designing prototypes, services, or systems with people in mind. By understanding their challenges, as Margareta just told us, involving them in the process, and testing ideas to make sure that they are working well for real users. In Ocean, we show that when you involve user early and continuously, seafarers, designers, and engineers, the results is more usable systems, lower workload, and safer operations. It's about moving from work as imagined, how we think things are done, to move to work as it's done. We also brought a couple of simple, low-tech tools for early usability and situation awareness assessment that are now proven in use and make it easier to get started with human-centered design. So I would say my advice to others is to start small, listen to users, and test ideas. Test the ideas early. And even simple tools like journey mapping, think aloud testing, and usability walkthroughs give valuable results and can be applied with limited resources. And please come and meet me in the break, and I can show you our assessment tools and how they can be used. Yes, thank you.
Thank you very much. So this means that there's actually a takeaway, a physical takeaway. So if people come and talk to you, you can show them a couple of simple tools that can be brought home and applied sort of out of the box. That's brilliant. Thank you very much. The next of the enablers that we have been working with in Ocean is what we call root cause analysis, But root cause in this case is something we put in quotation marks because we are firmly believing that many of the things that happened during the time are contributing to accidents, but there's not a single root cause. This is too simplistic to look at. So this is do you agree with that? Is it so that there is only one root cause, or do you also see this varied picture?
Thank you, Eric. Yeah, you're right. Navigational accidents are predominantly the result of a chain of events. They're often triggered by human error, but there are underlying influencing factors comprising technical or organizational matters, as well as human behavior. So yeah, there is not only one root cause in each accident. Through our work Notion, we comprise the list of such direct and latent factors that contribute in navigational accidents. We did that by reassessing past accident reports and conducting interviews with accident investigators and other experts. We are talking about factors like the lack of usability in tools and technology that Sunny told us how important it is. Crew fatigue or poor crewing levels, procedures and policies that do not match the way work is done, or the lack of maintenance in systems and software. But we didn't stop there. We used these findings to develop a new assessment method to support the mitigation of a broader range of risks to navigational safety. This tool, the Navigational Risk Awareness Template, is based on a set of ranked behaviors derived from our findings that are designed to mitigate navigational risks. By answering if they apply these behaviors or not, an organization can know where it stands in risk management and mitigation. It's a simple and easy to use tool, again, in line with what Sunny talked about, that raises our awareness, especially for latent navigational risk factors. For anyone that is interested and wants to take a closer look, there are physical copies in the exhibition.
Thank you. Thank you very much. And that, I mean, I hear that you're also widening up the concept of situation awareness. So it's not just something that happens in the moment on the bridge. It's also awareness of organizations. It is in the history. It is in the background also. It's not just in the sharp end of the business. That is very good. Thank you very much. The next thing we are going to talk about has a wide influence on performance. It influences leadership. It influences situation awareness. It influences collision avoidance, and it's all about training. And it's also a question of what is good training and what is a shortcoming in training, and are there gaps in training? And Ali is with us from London, and I think you have at least an answer to that.
Thanks, Eric, and thanks for the team. Can you hear me here? Okay.
It's fine, Ali. Just go ahead.
So can I start? Can you hear me clear?
We hear you loud and clear.
Thank you. Thanks, Eric, and thanks for the team and the panel. So within training, it has been said sometimes the regulatory framework is a bit slow, and because the maritime and shipping industry are dynamic and complex, and so while we are doing our work within the Ocean project, we did notice, and it was clear that there is a lot of gap in some areas which is considered important. And looking to that gaps, we also noticed that the way we deliver our trainings in somehow is not a suitable way to the end users or the seafarers at the end. So with that context, we thought about a different way. We looked not only from the failure perspective, we also found that within the maritime industry, there is a lot of good initiative, good standard, and companies, organizations, and training centers are taking further steps to support their teams and seafarers, and it is really effective and could be a guidance. So we thought about sharing this as well in a dynamic and digital way. So after a constructive research, we looked at these gaps and we delivered that in videos. These videos are mainly for institutes and universities. So they are used, we can use them in their curriculum and in their syllabus. And we achieved a good representation of that. And because these videos are free online as well, so we get a large number of views. With regards to the leadership and the non-technical skills, it's really important. And it's really important mainly for the seafarers because they are living on board. So these skills are not only used to perform duties, they are also used for them to socialize and to communicate with each other.
Thank you, Elliot. Thank you a lot. Just to elaborate a little bit on what you were saying, I believe that there are 7 videos. They are addressing 7 areas where we believe that improvements in training could be made. They are freely available to download on our website. They are on YouTube, and anybody is welcome to use them for their own purposes as long as they sign a very simple form and give the credits to the Ocean Project and to the Nordic Institute. Is that correct?
That's correct. They are free online, and there is a consent form, as you said. And we also are looking for comment and feedback from the end users, which will help us further in the future.
Thank you. I think that's a very important point also in the context of today, that we are seeking feedback. We are still looking for all the ways where we could improve the outcomes of the project. So thank you very much, Ali. Moving on, there is an arrow here that has a slightly critical name called system robustness. And our bold claim is that influences everything that is happening in the wheelhouse. And Jonathan, would you care to elaborate a little bit on that, please?
Thank you, Eric. Yes, I would actually start by asking another question. Why do we put seafarers on ships nowadays and in the future? The answer is to exercise meaningful oversight and control, to use the preferred words of the United Nations. In the past, this would have been meaningful oversight and control would be of a team of people. Nowadays, it is of complex, interconnected, software-intensive systems, pieces of technology, and a decreasing number of people, but possibly not in the same location. However, IMO has made clear that responsibility will remain with the seafarer, specifically the master. So we need people to responsibly use and manage software-intensive systems, to trust that systems are working, will work, and can be used. In other words, they need to be robust enough for the job and usable enough to support the seafarer in doing the job, and stable enough throughout their life to keep on doing that job whenever required. In other words, the software-intensive system shall be demonstrably suitable for the user and the given task in a particular context of use. It shall deliver correct, timely, sufficient and unambiguous information to its users and other systems, and the hardware and software of the software-intensive system shall respond correctly throughout its life cycle. Now, those aren't new words. This is the goal of ISO 17894. This standard was the first goal-based standard for maritime IT. It has served well for 20 years, but maritime IT has moved on. When the standard was developed by the European Atomos project, 25 years ago, the only IT on a ship was operational technology, the island's operational technology, control systems, navigational instruments. Now we have widespread use of software-intensive systems, increased connectivity and interconnection, and new applications such as AI. Many of these will be demonstrated today and identify a need for broader interpretation of risk and application of risk-based thinking. The Ocean Project has reviewed ISO 17894 and finds that its requirements for product and life cycle are still valid and applicable. They support new forms of assurance and are suited for the development of a wide range of modern maritime systems. And while the practice of software development in the maritime sector is very much improved, deeper consideration of risk and requirements and service management are needed to ensure robustness, usability and stability of software-intensive systems in maritime applications. An updated version of the standard has been written by Ocean, and yesterday, ISO Technical Committee 8 assigned it to Subcommittee 26 for review and publication. So we've gone from thinking about the need to having the finished document into the ISO process during Ocean. Copies of the public text of the standard and 10 full copies of the standard as formatted by the project are available from the same desk as standing upstairs. Thank you.
Thank you, Jonathan. I think it is so that there's a lot of copyright issues and so on around ISO documents. But is it correct that people can have a kind of a sneak peek if they look at some of our deliverables?
Yes, in fact, the 10 free copies are one of our deliverables. They're given to you on the understanding that you will provide feedback. ISO is happy at this stage in the development to get feedback. So they're not totally free. Please feedback when you read them. What's called the public text is freely available, and there's plenty of copies of that. So if you want to get an overview, there's loads of copies. Please take them away. Thank you.
Thank you very much. And that takes us forward to a question that has an impact on collision avoidance, on situation awareness, on the working climate, on the bridge. And David, the question is a little bit critical because it sounds, what does good look like? Do you care to elaborate a bit on that?
Thanks very much, Eric. I'm particularly pleased that you come to me for what good looks like. Ali explained earlier about the videos, and Eric, you put up that slide showing the 3 different stages of situational awareness. And Odie and Jonathan also elaborated a little bit that when we talk about this, it's not necessarily just on the bridge. It's a systematic thing. It's an organizational thing. And Eric, you speculated that you'd like us to ask questions and think about what might happen after the Ocean project. So I'm going to do that. One of the things that was very clear within the Ocean project and the human-centered design is that we engaged a lot of users in that design. We went into simulation, we did mock-ups, and Sandy, you did a lot of work on this, and we learned so much from the users. Now, one way to learn from the users is to build it, to break it, and then Enrico will look at it and say, it was a bad design. But there's another way. And this is what good looks like. And it's, it can be referred to as the safety 2 philosophy, where instead of waiting for an accident to happen and then figuring out what went wrong and learning the lessons from that, you actually look at who's not having the accidents and learn from that. And I think that's something that we need to do so much better in the maritime industry. We really don't do very much of that. And I'll give you an example. In the aviation industry, and don't get me wrong, I don't put aviation on a pedestal necessarily, but one of the things that they do is they have something called a LOSA, Line Operation Safety Assessment. And this is where periodically they have an assessor ride in the cockpit of the plane and observe. and they look for three things. They look for, is there competence? Because if there isn't, they know how to fix that. Train. They look for procedures. Are they following the procedure? Are the procedures right? The procedures may not be right. And then you change the procedure. And one of the things that we're really not good at in shipping is we're quite good at changing our own internal procedures. But when there's a bad regulation, a regulation that's causing confusion and distraction, we're not very good at saying, actually, that's not a good regulation. We've tested it, we've tried to abide by it, but it's actually a bad regulation. So what do you do about it? If you're a seafarer, if you're a superintendent, if you're a ship owner, it's really difficult to go back and say, that it's a bad regulation. So we need to get better on that. And the third thing they look at on a LOSA inspection is the design. Is the design fit for purpose? Is it working, et cetera, et cetera? And again, we don't do that very well. And my colleague, Captain Al Said, did a very extensive survey within the Ocean Project, asking mariners, hundreds and hundreds of mariners, why they don't report bad design. Because if you ever talk to a mariner, go into a bar sometime, find a mariner. Oh, they are all the places, but bars are easy to find. And say, have you ever come across bad design? You'll be there for a long time. And then you say, what have you done about it? Who have you told? And I'm like, oh, no one. And so Ali, in his wisdom, said, why haven't you asked? Or why haven't you told somebody? And some of the reasons, and it's in his videos and in the documentation that Ali's done for the Ocean Project, is it's too much paperwork. I'm swamped with paperwork. I don't need more paperwork. Or why? Who's going to listen? And there are all these things. So what the Ocean Project has very clearly shown that listening to mariners can make better systems. But it's a 3-year project. Who's going to listen to mariners as they get more and more experience, as systems design and evolve? And let me tell you, we have so much evolution in what's happening on board the ships. It is really imperative that the maritime industry does better, and maybe EMSA is part of the solution here, that how do we get those lessons? Is it port stay control? Is it accident investigation? Where do we learn about, and how do we create that cycle back? And if you go back to the 3 stages of situational awareness, you have, in my seaman speak, you have seeing something, understanding something, and doing something. Well, we're at seeing something now. We see a lot of new technology, a lot of new tools, AI. We see this stuff coming on board the ships, but we don't understand how it's working, and we don't know what to do when it's not working right. So that's what I would like to do, is focus on what good looks like, who's doing it right, and learn from that before Erico has to deal with it. Is that right, Eric? Sorry, I'm on a soapbox over here.
Thank you very much, David. I think this is possibly the perfect hook for Enrico, because you have now had the opportunity of making yourself slightly familiar with ocean, and you can see that there's a technological outcome, there's a lot of procedures and so on. And do you see that this is a twin-edged sword? Are there both challenges and opportunities in this, or how do you see it from your perspective, from EMSA's perspective?
Many thanks for the invitation to be part of this panel, first of all. And well, let me say that I heard that very carefully that their colleague is here. And words like local rationality, certitude, human-centric design nicely resonates with me. At EMSA, we are supporting accident investigation bodies, so the authorities that are in charge of conducting the safety investigations. And it's very interesting that there is a change. There is a movement from the traditional way to investigate, which normally was stuck to the human error. So blame the master, to a more systemic approach.
And many organizations are more oriented toward these system thinkings that allow to capture a lot of additional domain that are behind the accident. Because now it's commonly recognized by the accident investigation community that an accident is a complex socio-technical occurrence. So you cannot limit yourself to read the master or to focus on the human error. EMSA made a few years ago a comprehensive safety study on navigational accident based on the safety investigation report in the European database for marine casualties and incident. This analysis can be downloaded free of charge from our website. And it's very interesting to notice that a specific checkout is about technology. Technology on board the vessel is widely recognized as facilitator for seafarers to do their job, to increase safety, etc. Nevertheless, investigations show that under certain conditions, technology may become a burden. For instance, just to give some example, the way alarms are presented, the way this is configured, possible interaction between radars and other systems. I heard the importance from this panel about ergonomics. Well, let me say that we found issues reported by the accident investigation bodies concerning, I would say, technology conflicts and ergonomics issues in some 85 safety investigation, which is quite a lot, I would say. So, yeah, I personally see this the Ocean project from my perspective as very promising. In my view, it fully encapsulates the modern way accident investigation are conducting their investigations, and it's fully aligned with the new needs from the seafarers, from the industry, and from the authorities. Thank you.
Thank you very much. Very interesting, and I hope we will be able to pick up on this later in the day. Is it so that we can already now ask, are the findings from that study available to especially those who design instruments at sea? Because it sounded like there is a gap between what current designs look like and what they could look like in order to improve for the seafarers. Do you care to comment on that, Enrico? Or anybody?
So, sorry, Eric, are you talking about the research?
Oh, what is this? No, I was just reflecting on what Enrico was saying, and that we have data that could have an impact on design of maritime instruments because there was noticeable shortcomings, and how we can make that operational to support the seafarers in a better way.
Thank you. From my perspective, I think that I clearly see the opportunities. The way the project has been conducted and its outcome, the involvement of the stakeholders, talking with the sharp-end users, etc., I think is very interesting to create some concrete follow-up. I also noticed from your presentation that the system is not just an additional tool that you put on the bridge, but it's something that is supposed to nicely work with the existing equipment. And this in turn may have also some benefits in terms of training. If seafarers are acquainted with the existing tool, shouldn't be, a breakthrough any system that should work together with the systems, with the existing knowledge, and so on.
Thank you very much. We have now been sort of given high level input from the panel, and the floor is open for questions. Anybody who wants to answer or ask anything, or is intrigued by what you've heard, or Any questions? Are there any questions in the chat? I don't know. Person? Hello, Eric. Can you hear me from here? Great. We have one online from question. As Jonathan has mentioned, there might be AI component into this project. So can AI be an enhancing element to the ocean project? And that's it for the question. Please, Jonathan. I think the question was there.
As you'll find out during the day, we have used various forms of AI within the project for processing information and to assist navigation. So you'll see some examples in the project. I think as our host said at the beginning, there's an awful lot going on. From the point of view of robustness, we need to be sure that we apply the same standards and expect the same quality from AI technology as we have for other applications. So that's still under development. As was mentioned, the regulation is catching up. For the moment, though, the application is likely to be near shore and visible and analytical. So in other words, if you look carefully at ocean, it has applied AI in many ways. And we have thought to some degree about how to assure it, which supports this overall requirement from IMO that it will always be under human control. Thank you.
Thank you very much. I think I would like to go back to so a kind of an overall assessment of ocean from a safety perspective, and I think you may be the one to best elaborate on that. So with all the things that have been done, given adoption, do you think this will lead to safer navigation that can actually be assessed? Or certainly yes. We used during our work the tool that we developed that I mentioned earlier. We implemented it to assess the overall ocean results. We conducted interviews with our partners, and we performed a desk exercise with all the reports from the project to try to correspond them to these behaviors that mitigate navigational risks. And we were pleased to find that all of the pieces of ocean, all the parts of this project had a positive impact on many of these behaviors. So we firmly believe that ocean can lead to safer navigation. Thank you very much. I think this makes my day, because in the joint effort of what everybody have done to point towards greater safety and navigation. So thank you very much. I think we are about time. If there are no more questions from the room, there was a question there. Good. Thank you very much.
Thank you. Hi, everyone. This is Miriam, and I have a question for Enrico. I hope I pronounced the name right. Okay. I want to know, like, if an AI-operated vessel has some malfunction and it goes missing, what are the existing protocols to know what went wrong exactly? Like, are the persons trained in this regard to track down the AI-operated vessel?
Thank you. And pronunciation is perfect. So your question is about the current protocols for investigating malfunctioning and so on. So let me say that
There is not a single shot answer. In academia, there are more than 100 methods to investigate accident, depending on the focus of your safety investigation. Sometimes you may focus more on a specific failure for equipment. And then, for instance, fault tree analysis is generally followed by many accident investigation bodies. Sometimes, especially for navigational accident, when there are different parties involved. Think about a collision. You have not only one vessel, you have two vessels. So two chain of command, different companies involved and so on. So complexity increase. And then the focus and the approach is different. Normally is not focused on the failure of a single piece of component, but is a more holistic and systemic. So this is basically this is left to the Accident Investigation Authority. They are independent authorities, so they are totally free to decide which kind of methodology to apply. But as a rule of thumb, I would stick to what I said. So normally, if you want to investigate the failure of a specific component, you can follow a more linear and deterministic analysis method. When it comes to more complex socio-technical occurrences, then the focus necessarily needs to be different, focusing, for instance, on the interactions of the various parts, communication issues, decision-making process, safety culture on board, and so on. Let me also say that this kind of investigation also normally requires a lot of effort and energy from the accident investigation bodies to gather evidence and to analyze, because we are talking about lots and lots of information and data.
Thank you so much. This clarifies the question.
Thanks. Thank you very much. I think that I'm about to let the panel off the hook. We are on time, and if we need to follow the schedule, I think this was the closing remark for this panel. So please. Andrew. Oh, a little bit for your efforts. Oh. Oh, I need to grab one. They will do a bit on That's very good. Thank you very much. Thank you. So this takes us to the next thing, and this is like if it was a commercial, they would say this is a message from our sponsor. But in the way it is, Agnieszka is our project officer working with CINEA in Brussels, and please come and share your view on the need for a project like Ocean. Thank you.
Good morning, everyone, and thank you for inviting me as the project officer for this project. My name is Agnieszka Zapłatka. I'm working in CINEA, which is European Climate, Infrastructure and Environment Executive Agency. It's an agency that implements various programs, but including Horizon Europe, under which this project received funding, of course. I was asked to speak about the need for results of this project, which is quite interesting, having in mind that the last hour, at least, we've been talking about why these technologies, these solutions, human-centered design is needed. So I have a very interesting task. But as a project officer responsible for implementation of this project over the last 2 years, it's, I think, a great pleasure, a great honor, and also very interesting experience to, for the first time, I think, in my career, introducing the project in the
premises of the institution, of the agency that is implementing the regulations, the requirements. And I think this is the most interesting point of this event, that we are really introducing results of the project that is currently ending, of the very pertinent, addressing very pertinent challenges of situational awareness, improving situational awareness and safety of navigation. So we are gathering today not only to celebrate the conclusion of the project, to promote its results, but also to kind of pave the way for future of safety of navigation. The Ocean Project delivered, as you could see, quite an impressive amount of various results from developing application supporting navigation, from to developing training procedures, to also revising regulatory instruments, suggesting solutions to how to improve them. And the other biggest added value is that this project also included lots of stakeholders, involved lots of stakeholders, listened to their experience. And this is, I think, super interesting. Learning on real life experience with a new fancy name from Horizon 2020, which ended in 2020, to Horizon Europe. And in 2021, this call addressing dual challenges of safer navigation and tackling container ship fires was launched. There were two proposals which were standing out and got financing. One of these is the Ocean Project, and the other one is a SafeNav project, which will have its point in the agenda in the afternoon tonight. So you're going to hear about that. These two projects are addressing safety of navigation. And they are to a certain extent complementary to each other. They are tackling those challenges from a bit unique perspectives. Both were supposed to show technological solutions or training, develop training procedures, but they approach to it from a bit different perspective, but towards the common goal. One is focused a bit more on commercial applications, and the Ocean is focused on this regulatory, on really bringing technology in a more open way. Both projects, Oceans and SafeNav, started in 2022, which is the year that EMSA published their MSAFE, the first MSAFE report, which presented an overview, very comprehensive overview of maritime safety landscape in the EU. From this report, what really was striking me was that despite SOLAS Convention being very widely ratified, its implementation still reveals significant deficiencies. This rapid evolution of maritime sector places unprecedented demands on seafarers. Lots of individuals who are integral to operational safety face these new challenges on daily basis. As Captain Patraiko mentioned, they are overloaded with lots of information, beeping alarms, screens, and so on. Therefore, this is what exactly this project is bringing. The human-centered person, the crew in the center of the design of this whole system. EMSA also, I've learned, is addressing these issues. So hopefully what project developed is bringing relevant input to also the work of EMSA. I think the coordinator, Eric, already explained very well the developments, the results of the project. Therefore, I'm not going to go through that. But I would like to mention that beyond technical innovation, beyond this toolbox that the project delivered, project is also actively involved in shaping policy. There were several submissions to the IMO delivered already to various subcommittees. The subcommittee on navigation, communications, and search and rescue, the subcommittee on ship design, and to Maritime Safety Committee. There are additional submissions planned, contributing and accepted as information paper at the IMO. We've learned about the revision of ISO standards. The collecting feedback on those revisions, on the training procedures, on the results of the project. That is something that really stands out and makes a difference. In conclusion, I really wish that developments of the project, the Ocean project, and other R&I projects focused on human-centered design would add to a real practical contribution to improve maritime safety. And I am very happy to be part of this journey. I wish you a great event. Thank you.
Thank you so much. Thank you for the kind words. You should have had another background, but never mind. Oh, Agnieszka, please come on here. I think we need to keep this for eternity. Thank you so much. Thank you. And now to something that we might have been waiting a little bit for. There is time for a break. There is coffee upstairs for those who are here with us in Lisbon. I hope you who are online or in other places get time to grab a cup of coffee and kindly be back here by 11:45. Like I said in the beginning, we are really on a timeline and we will start on time at 11:45. So kindly be back in the room. And meanwhile, enjoy and go and have a look at the exhibition. Thank you. Okay, right.
So I hope the coffee break went well, and you are a little bit refreshed to the next panel that we're going to have today here on the Ocean Final event. We're now changing focus a little bit, and we will look at some technological development that has been done in the project to help seafarers to become safer. But it's an interesting added dimension that this was developed with a strong impact of human-centered design. So in my experience of the maritime industry, this was an example to follow. Cutting edge technology and keeping the user centered in the design thinking, in the development, in the testing, and so on. I'm standing here with Captain Matt Lynch of the Irish Ferries, and Matt has try and move here, then you're on the picture. Yeah, Matt has promised to moderate this panel for the next 40 minutes?
40 minutes.
So, yeah. So over to you, Matt. Thank you very much, and enjoy.
Thanks very much, Eric. Good morning. Help me navigate through this segment, this debate here, providing improved information, better situation awareness, and decision support to the watchkeepers. We have our panel here. My role in the project has been the snarling seafarer. These guys have been the experts, have been doing the hard work to develop the system that's been provided. So if I can just introduce our distinguished panel here and also their role within the project. We have Vidar Helgas. He was the overall project manager for the development of the 4D SAD. Also have Captain Jacqueline Burton, is the director with Kongsberg Maritime of Experience and Design, and her team was heavily involved with the overall design and the way that the 4D SAD looked for the end user. Dr. Sani Shamoon was assisting with the human-centered design research as part of the project and to help with the development of that. We have Helena Ranginess. Helena was the project advisor, or is the project advisor with Kongsberg Maritime for the advanced manoeuvring systems, and was heavily involved with the development of the Evasive manoeuvring agent and the advice for the operators. Lastly, and by no means least, Henrik Voss. We have the Vice President, Navigation and Positioning at Kongsberg Discovery. And Henrik was involved with the sensor and data integration within the unit. So that's the panel we have here to navigate us through this subject.
Seafarers are experts in navigating vast oceans and safeguarding their crews and cargo. However, being aware of all potential hazards, especially those hidden in low visibility or below the surface, remains a significant challenge. Accidents at sea often stem not from a lack of skill, but from risks that are obscured or detected too late to avoid. Imagine a world where navigation is significantly safer, with enhanced situational awareness for those at the helm. This is the vision that the European Union and the United Kingdom aim to achieve through the Ocean project. Central to this initiative is the Ocean 4D Situational Awareness Display, a cutting-edge tool designed to enhance navigational decision-making through seamless integration with existing bridge systems and sensors. Unlike prototypes or mock-ups, the Ocean solutions are fully developed technologies, including the 4D SAD, the Evasive Manoeuvring Agent EMA, reporting app for handheld devices, and the European Navigational Hazard Infrastructure ENHI, which ties everything together. With a technological readiness level of 7, these tools are being demonstrated in operational environments, confirming their reliability and real-world functionality. They are modular, scalable, and ready to integrate into current maritime operations and instrumentation to enhance safety and situational awareness. Let's explore how the Ocean 4D SAD transforms routine navigation into a safer, more efficient experience, even under challenging conditions. The MV Global Navigator is making its way on a foggy morning. With reduced visibility and strong winds, the crew, a captain and a watch officer, are relying on their instrumentation, supported by Ocean's 4D SAD, to maintain situational awareness. The journey begins smoothly, with the system providing an at-a-glance summary of critical data such as heading, speed and wind direction. However, the challenges quickly escalate. As the Global Navigator approaches a busy shipping lane, the Ocean 4D SAD identifies a cluster of vessels converging at varying speeds. The system's collision avoidance controller highlights critical targets in magenta or red, depending on criticality, and displays their closest point of approach and the time to closest point of approach directly on the chart, which helps the crew to prioritize threats and adjust their course preemptively, avoiding potential conflicts. Then visibility drops further as the vessel enters a dense fog bank. Due to signal clutter, traditional radar becomes less reliable. The Ocean 4D SAD overlays a transparent, real-time representation of nearby vessel movements using data from AIS and advanced predictive algorithms. It also pinpoints a previously unmarked floating hazard, a drifting container, and marks it as a red alert on the display. The crew quickly adjusts their trajectory to avoid the obstacle. As the Global Navigator continues its voyage, it enters an area known for marine mammal activity. The Ocean 4D SAD's mammal indication feature highlights zones of recent sightings with expanding probability areas. The crew slows down to reduce the risk of a collision and reports a sighting using the quick reporting tool, contributing valuable data to the ENHI platform. Near the destination, the vessel encounters a fast-approaching ferry on a collision course due to an apparent miscommunication. The Ocean 4D SAD escalates the alert state and provides a trial maneuver simulation showing the safest evasive action. While the captain follows the recommended course, the evasive manoeuvring agent remains on standby, ready to intervene if the crew is unable to act in time. As a backstop safety measure, the evasive manoeuvring agent can take over control in the rare event that the crew is unable to respond even after multiple alerts, ensuring that in such unlikely cases, critical maneuvers are still executed, adding a vital layer of defense. The human operators retain full control in all standard situations, with the evasive manoeuvring agent only stepping in when absolutely necessary. This scenario demonstrates how the 4D SAD integrates seamlessly with existing tools to provide a layered approach to safety. By highlighting critical information, reducing distractions, and offering actionable insights, the system empowers seafarers to navigate complex situations with greater confidence and precision. To learn how the ocean tools can integrate seamlessly into your existing infrastructure and enhance your operational safety, contact the University of Western Norway today.
Okay, so that whets our appetite and introduces what was designed at the end of it. But I'd like to start with our panel to understand a bit more about the context. In EMSA's own statistics, they suggest that in 57% of navigational accidents, the seafarer didn't actually see whatever it was coming. So surely, Jacqueline, that just means the problem is a human error related problem. Isn't it just the seafarer that's just not doing their job properly on the bridge?
Well, I think the very short answer to that is no. And actually, it was really nice to see Enrico on the earlier panel pick that up, because the seafarers are operating in a very complex socio-technical system. There are a lot of challenges that they face, and it's very easy for them to miss one piece of information one time. The question is that time actually the time that causes an accident? And in the case of that statistic, it is. But why do they miss that piece of information is really the question that we should be asking. And one of the things that we were looking at in this project was, how do we actually put the relevant information in front of them and make it visible to them? And as you saw in the video, and as we have done in the project, we learned a lot about alerts and a lot about how alerts can be missed. When we started in the project, we had the idea that we'll put the big banner on the top and they'll be able to see that. But actually, it became part of the background for a lot of the seafarers when they were in a critical situation. So when we took them in and we had the paper prototypes, then yeah, that's a great idea. It's good like that. But when we actually test them in practice, that wasn't the case. So we ended up putting the alerts very close to the dangerous target so that it was tagged in the screen in the visual area where the seafarer was actually concentrating their attention. And when we're looking at overall how the systems are put together on the bridge right now, they're not necessarily put in the face of the mariner. They're on many different screens and very diluted. And so when we went to make this solution, we were looking at how do we actually integrate all of that information and what's important for the alerts to make good tactical decisions for the seafarers more simple.
Thank you. So as I understand it, then we've decided that it shouldn't be the seafarer integrating all the various different bits of equipment on the bridge, but we're looking to design something that's going to help them to be able to do that. So, I mean, I'm going to move to Dr. Sani now. Obviously, one of the early intentions of the project was to involve seafarers in the design so that we could learn from them and understand the environment that they were on the bridge and some of the challenges, particularly when faced in stressful situations or if things did go wrong. So where do we start with that, Dr. Sani? How do we start and embark on a human-centered design process, which hasn't really been tried before?
Yes, as I told earlier when I was participating in the earlier panel, I said human-centered design is really about involving the people who will actually use a system. And when you do that, you will have the opportunity to take in different people with different experience and knowledge. And as you say, Jacqueline, from the beginning, the idea can look really good. But as you proceed and test again, and again, you will find that maybe that was not the best solution. So this is what we did in the Ocean project. We applied human-centered design step by step. And I can tell that sometimes it felt like we took one step forward and two backwards. Because it's about dealing with different persons, with different competence, coming from different backgrounds and cultural. So, and no one has the time. So there was some challenges into the process, but we did it. And by doing it in incremental cycles, we invited seafarers to comment early on sketches, mock-ups, and prototypes. And later on, we did full-scale simulator tests. I think we proceed with 3 or 4 simulator tests. And each step gave valuable feedback. So design, adjustment, and improvement could take place before we were moving further. And this example with this banner with a big alert on the top of the screen, as you were talking about, was a good example how when you involve the seafarers, the end user, you understand them and their needs. And I think the reaction from the designer first was, okay, we should make this banner bigger, or change the colors or make it flashing and sound. And the reaction, I think maybe you were one of them, Matt, that were saying, no, 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 stop. We don't want more alarms on the bridge. We are fed up with alarms. And I think you did it the right way from the team, that we're listening to the seafarers and ask them, where do you want this alarm coming, this kind of information? And they said, it's much better if it comes where we are looking. So yes, this way usability and situation awareness were tested early, and not just at the final stage. Another good example is the demo sit test that we finished up with. At that time, we brought in new end users. They have not seen any mock-ups or prototypes earlier. They have not participated in the simulator test. So this 4D SAD was a new equipment for them. And they were given a short introduction about how it worked. And they gave really good feedback on the 4D SAD tool. And that was that they really liked it, and it actually worked in a real environment on the bridge. So with that said, I think it proved that working step by step and test the product and the design early with the end user, you will get a good result.
I think it's also worth saying that they didn't just give comment on the 4D SAD, they actually used it to operate the vessel from. So they weren't using all of the other bridge equipment at that time during that test. They were using the 4D SAD to actually do their tactical navigation of the vessel and operating that environment with a very short introduction. So it had a very short learning curve where they didn't need to spend a lot of time in introduction before they were able to actually operate the vessel in a good way.
Thank you. During the project, a service engineer mentioned to me that seafarers can be quite challenging and had very different opinions. And he recounted the story of a chief engineer he once spoke to that asked him to put a particular widget on a certain device in a certain area, and that was put there. And the next time the service engineer attended the vessel, the widget was asked to be put somewhere else and somewhere differently. And so his overall conclusion was that the seafarer can't be relied on to know what they really want. So, I mean, I'm just interested in the panel's opinion on that and how useful they found the seafarers' interactions during it. And because we are a little bit short of time, question for Jacqueline as well, because you'll probably take that statement, is just the team and the approach to the overall design. How did it maybe differ from other products that have been developed in your organization?
I think this one in particular, because we were looking at how to combine everything into one display to make tactical decisions, because you have different types of goals that you have on the bridge. You have planning goals and passage planning, and that was not what we were looking at in this project. This project, we were looking at actually how to enhance the situational awareness in their actual operations tactically. And in this project, we didn't have a lot of the constraints that we have with the traditional products that we make. It's not radar. It doesn't have to be compliant with everything that radar has. It doesn't have to be compliant with everything that ECDIS has, because it's right now designed to be delivered alongside those as an additional tool. And because we had that freedom, we were able to really reduce the amount of information contained in the system and in the display and the number of user configurations and options that are available also in the display, because in those other systems, you have a lot of configurations that are required to be there. So we are able to look at it from how they actually operate and how they need to operate, and be a lot more flexible in not only listening to the seafarers, but actually giving them what they need and not necessarily what they wanted or asked for. Because if you ask any of them, they want all the information possible, all of it in one screen. And that's not necessarily good for situational awareness, because it dilutes their ability to be able to process that information and find what's important. So we're really focusing on what is important for them in these tactical moments, and including only that, and reducing really everything else to remove distractions from them in their decision-making process.
Thanks very much, Jacqueline. So we looked a little bit as to what we saw the challenges and the approach to the design. There is really a technical element to this. So I'm gonna go to Henrik now, just to we've made some bold statements in the video and the project overall in terms of situational awareness and decision making and the ability of the system. So what goes into it to help? Yeah, thank you. Well, our role in this project has been to be a sensor provider, to create the information that you need to create this beautiful, simpler, easier displays for the seafarers to use. And for us, it's a bit of a paradox, right? Because to do something simpler, you need something more advanced on the sensor side. So for us, this is a shift from having multiple different sensors, not interconnected, not working together, and turning that around and building a new layer on top, which has the responsibility of creating really a unified world model of what is around the vessel and what kind of information do we actually need with regards to safe navigation. So for us, it's about digitizing the perception tasks within the navigation. And in this project, what we built was that we created a system that interfaces to AIS, it interfaces to raw radar data, it interfaces to both normal cameras and infrared cameras. And then on top of this, you build a layer of perception. So you build machine learning models to interpret this kind of data, and then fuse all of the data together in the end to create this unified data model. And why does this? Why is this important? Well, why does this matter? Because it's really back to what are we trying to do here? Well, we are trying to make information, the information that is shared with the user in such a way that it's simpler to understand. So you can't have several different sources talking or giving information about the same obstacle, for example. So for us, it's about creating a sensor system which is an enabler for better situational awareness, to lower the cognitive load and to enable new systems on top of our systems that can do advanced decision support. And this then comes back to how we created something as a whole in Kongsberg with regards to the Ocean project. So with the Evasive Manoeuvring agent and the 4D SAD, which builds on top of the data which we create in the sensor system. So maybe Helene wants to talk a bit more about the Evasive Manoeuvring agent.
Yes, I will try to explain a bit then how we are using this data further. So as Henrik has told, they are giving like a unified picture on the surroundings. And in addition to those data, the EMA is also interfacing more traditional systems like the ECDIS to get information on the charts. And all this information together is like giving the full picture out on the surroundings that the EMA is using for its calculations. And what it does then is that it is trying to calculate a safe collision and grounding-free maneuver for the operator to follow. And it's, of course, also taking call regs into account. So it's classifying each encounter with respect to call regs, and that information is also given to the operator to try to give the operator an understanding of why it's doing or suggesting that particular maneuver. Vessel dynamics is, of course, also important here. You want to create a maneuver that is feasible for the vessel. So it takes into account speed limits, acceleration limits, rate of turn limits, of course, the size of the vessel and the size of the other vessel, and so on. And then it calculates the optimal maneuver, and this process is continuously ongoing, so it will give updated advices all the time with the current picture of the surroundings. And of course, if there is nothing there, it will just advise to follow the nominal route. But if there is an encounter, for instance, a potential collision to another vessel, it will give an advice, a maneuver advice to avoid that vessel, call regs compliant, of course, and it will also start an escalation process. And it's integrating towards existing alarm systems on board. So first it will give a warning that there is a risk of collision. That was also shown in the video. And then at some point it will escalate to the next level following the BAM standard, and it will give an alarm. Now you're getting really close here. So operator, please do something. And it will also start a countdown on what the system thinks is the last time to actually do a maneuver. And at the same time, it is also triggering the BANVAS on board, giving this audible alarm, both on the bridge, but also other places on the vessel, in case there, for some reason, the operator on the bridge is it's not there, it's not doing anything. And then when the system reaches this last time to maneuver limit, it will actually then take control. And it does that by sending new set points to the autopilot on board, and then it actually steers away, doing an emergency maneuver. So it is a quite, you could say, steep maneuver to get away. So that is kind of the last resort if nothing is done. And of course, at any time during this process, the operator can take control, and then the system will back off. So it's not like overriding the operator. If the operator starts doing a maneuver, it will stop. So yeah, that is kind of the short explanation.
Thank you, Henrik. Thank you, Helena. Conscious of time here, we've got a few questions coming in from our online delegates, but I'd just like to ask Vidar. We've been calling a system up to now a very complex piece, but of course the final thing is the 4-dimensional situational awareness device. So from a simple sailor, what is it?
Yeah, it's been mentioned here several times, but this, of course, this 4D SID is where everything comes together. Everything we learned in the Ocean project, and of course, integration with all existing equipment on board comes together in this one display, and that has been quite a challenge actually. So when we started this, the first design here, we had to test several times to make it what it is today. And the biggest challenge is when you have all these information from all these sources is to reduce information, only show the essential information. So again, by using
this processing of the sensor data that we have in the SA system. We have one list of targets to display, so we don't have to look at the AIS or radar, whatever. So we have one list, and also from the ECDIS system, we get chart and grounding data, and we only show essential data here with coastline and grounding areas. And also, of course, from the hazard infrastructure, we get the whale information, and we have designed new symbols here to show whale areas and also targets, and also, of course, integrating the maneuvering advice from the Evasive maneuvering agent. And again, while removing all non-essential data here, only the information related to safe navigation is present in the picture. And by developing this in this human-centered design process, that has been a very nice experience for us in Kongsberg. We have learned a lot, and I would say we could never end up with this such a good user interface without this process and without the involvement of the end users. So that's been very valuable for us, I would say. Yeah.
Thanks very much, Vidar. We've only got about 8 minutes left in this session now, so I think it would be good to take some questions from the online delegates. So I understand they'll ask them. So, Ericsson, if we have any questions.
Can you hear me okay? Great. Hold on a second. We have a couple of questions from online. When you're doing human-centered design, is there a difference between what people want and what works best? I know that's briefly addressed, but can you elaborate on that, please?
Yes. That's something important, that you have to look to what people really say. Why are they saying that the design is looking good and so on? You need to understand and have the knowledge of, as Margareta was talking about earlier, the decision process, also the situation awareness, how the cognition of human being are, as a social human being, how we are affecting each other in different contexts. So this kind of conditions are important to understand why people are saying what they want, or when they are saying it. Yeah, maybe you can add to that.
Yeah, there's kind of a famous quote. If you ask people if they want to get around faster before, that they're not going to ask for a car, they're going to ask for a faster horse, because there's not a context of the new for them. There's only a context of their current operational experience, the current way that they do things. So a lot of operators, if you ask them, most of them won't ask for this. They'll ask for an easier way to do this on the radar with everything integrated. They'll ask for a lot of information on here. But what you have to actually look at is, what do they need to solve their operational goals and problems? And when you're looking at the tactical goal of operating the vessel safely, then a lot of what they would think that they need is not necessarily what they might actually need. And that's where the user tests come in, because as you take things away from the screen, is it deteriorating or increasing their ability to operate? If you have too much information, and that's also the same with the north up, head up kind of conversation. And I know that we've gone into it so many times in this project. And a lot of the mariners really are still a fan of north up, but it's actually an artifact that has taken hold in the industry of the analog. It's the same as if you put a gauge and then you make a digital version of that gauge, when actually maybe a small trend would be easier for them to operate from. It's just because that was always the context that they used. And so that's the context that they expect in the future. And as we're looking at really improving the reasons why information is missed, that's important, it's because they have a flood of information available to them and they have to integrate all of it. And I think that that's where a lot of the challenges are in listening to the user and giving them what they asked for versus giving them what they need to reach their true operational goals. And I think that's where, the energy should be focused when we're working on human-centered design.
Thanks, Jacqueline. Thanks, Sunny. I think we'll take a question from the floor here, if there are any questions from anyone. Run.
Thanks, Matt. Speaking on behalf of ship owners, I'm just wondering if we were to move towards installing a 4D SAD on our ships, what preparation we need to do, and how can we ensure that the crew are well able to use it effectively and safely?
Thank you. Theodore, do you want to take that one?
Okay, I can try to answer that. So first thing, of course, the user-friendly design makes it quite intuitive to use. So that's a very good thing to start with. And also during the development here, we have used simulators extensively, and that can also be adapted in training seafarers. So I think these are kind of the two things that are most important. Yeah.
And I think just to underscore that really is, the final test with the guys with a big smile on the face when the two random seafarers arrived on the test vessel with no experience or knowledge whatsoever of the device were able to pick it up immediately and be able to interact and actually navigate the vessel safely straight off the bat with that. And I think that's quite a testament to the usability of the system. I think this gentleman here had a question, please. This will probably have to be the last question, I'm afraid.
Thank you. My name is Jin from Aeronautics, Korea. As a system developer, I'd like to mention that human-centered design, and the term itself is a kind of more blaming more human for accident. That means if we say something on the human-centered design, that is on the premise or some assumption that the human is main factor of the accident. More about 80% of the accidents are caused by human factors. That is, many researchers are saying in that way. But I like to say that what about saying in a different way, situation-centered design or case-centered design? Because the human is responsible for dealing with some situation. When we fail to dealing with that situation, that could be a result of accident, or that can be resulted in accident in that way. So the problem we need to really solve is the situation. So in that case, if we are more focusing on the situation itself, and then we can incorporate all the components or all the actors that can resolve that situation, including human and machine and systems and whatever. So I like to propose that kind of approach, which could embrace all the human-centered design concept and more directly approaching the problem.
I think there's some fundamental maybe misunderstandings here. Human-centric design is a process of design. It is not related to what had been called in accident investigations before human error. It's completely different concepts, not related. And I think that if we were to change the way we look at it and say, well, actually, we want to have a system approach or a goal approach, then you're looking at a removal of the human from the set of requirements. And people don't operate separate from their technologies. People operate with their technologies to achieve goals. And if you don't focus on the human users and their experience of use in their context of use, then you're probably going to develop the wrong thing, because you will have a fundamental misunderstanding of how they actually achieve those goals. Because the important thing is not the goal. The important thing is the way that they achieve it as a system of a human and their tools. And if you're looking at just the development of the tools, then you miss the plot. And I think that that's maybe where this industry has a lot of challenges, because so often they look at the technology as separate from the people who use it, and it is not separate at all.
Thanks very much, Jacqueline, and thanks to the panel. I hope we've had the opportunity to convey the pride all of them have in the project and what's been achieved from it. I think we've cantered through a lot of data and information there, but what you've seen is a means of integrating seafarers into a design process, a way of developing a system that can be pretty much used off of the shelf by integrating seafarers into that process. And a truly impressive piece of technology, which is up there at a level 7 status, and is able to directly assist seafarers in making better decisions and enhancing their overall situational awareness. So I'd like to thank our panel very much for their input this morning. So just to round off this session, I would very much like to thank you, Matt, for doing a great job. I think it was a good session, and we will now move on to something maybe. Thank you. Yes, I'm told that exclusively for those here in Lisbon, there is a photo opportunity that is supposed to take place outside of the main entrance, like now. And only then will you be permitted to start eating. Thank you very much. Good afternoon, all of you, and good to see you back. I hope you enjoyed lunch. I did enjoy lunch, and there was a good conversation going on around this. So this was really pleasing. We're now ready to move on to the next panel discussion. You saw in the foregoing that the 4D SAD is capable of showing missing or floating containers, but also showing marine mammals. And you might have wondered about where does that information come from? How do these guys collect that information? This panel is all about that. It's all about from the source of that kind of data to the presentation of that kind of data. So we have a human-centered design component in the app. We have full focus on hazard detection, hazard information collection and distribution, and that has an impact on decision support, on usability, and on situation awareness for the watchkeeper. And I'm standing here with Captain Brian McKenna from the Irish Ferries, who have bravely promised to moderate this session. So I'll turn over to you. There we go. Thank you, Brian.
Hey, thank you, Eric. So welcome everybody to the first afternoon session. We'll try and keep you entertained after your lunch. As Eric said, we're going to concentrate on hazard detection and hazard sharing. And we have a very esteemed panel here beside us, which I'm going to introduce. So first on my right is Dr. Rui Prieto. Rui is a researcher from the University of the Azores, specializing in marine mammal ecology and conservation. So Rui has led the ocean team developing the systems to inform navigators about the presence and location of marine mammals. Next, we have Francisco Rodero. He is an informatics engineer and intelligent transportation systems project manager. He's at the International Center of Numerical Methods in Engineering. And Francisco has been working on the design and implementation of the European Navigation Hazard Infrastructure, that's the ENHI, we've already heard about, and its integration with the rest of the developments in the Ocean Project. And next we have Dr. Simon Barrow. Simon is CEO of the Irish Whale and Dolphin Group, or IWDG, which is an all-Ireland NGO that coordinates stranding and sighting schemes and which empowers citizen scientists, including mariners. The IWDG has led the Ocean Reporting App project. Ludwig Wenigen is a research engineer at UPC in Barcelona, working on signal processing and machine learning and their application to biodiversity monitoring. So Ludwig leads the project on automated detection of marine mammals using acoustics and satellite imagery, and has led that element of the Ocean Project. And last but certainly not least, Mr. Harvey Stolinga is the R&D director at Teledyne Marine. Teledyne Marine designs and manufactures instruments used to monitor and explore almost everything below the surface of the sea. And Harvey has led the Ocean Project on the use of acoustic buoyage to detect marine mammals. So on that note, we're going to roll a video to introduce this topic.
Accidents and incidents at sea occur not because seafarers lack skill, but due to a range of underlying factors, from unrecognised risks to unforeseen circumstances. Across the world, increasing traffic adds complexity, particularly in areas where vessel routes overlap with habitats critical to marine mammals. These shared spaces demand a heightened situational awareness in the crew to ensure both maritime safety and environmental protection. Imagine a world where navigation is significantly safer, with enhanced situational awareness for those at the helm. That vision is precisely what the European Union and the United Kingdom aim to achieve through the Ocean Project. The Ocean Project has developed tools that are now at technological readiness level 7, thus poised for early deployment to tackle serious issues like collisions between ships and whales, a critical problem recognized by many stakeholders, NGOs, coastal states, and the International Maritime Organization. Importantly, the ocean ecosystem integrates into and takes advantage of existing systems already in place on board the vessel's bridge. The ocean solutions are about sharing data to keep everyone in the loop and safe. Now let's see how these tools can come together in a real-world scenario. Imagine a bustling morning in a beautiful location. Passengers are boarding a ferry for their journey, while nearby, hydrophones detect the presence of whales a few nautical miles away. These underwater sensors detect grey whales, while satellite imagery optionally supports long-term detection of the animals from above. This information flows seamlessly to the European Navigational Hazard Infrastructure, or ENHI, where datasets are consolidated and shared with the ships in the area, as well as shoreside operation centres and vessel traffic services, all equipped with the necessary tools developed by the Ocean Project to monitor the situation. From such shoreside facilities, information from the ocean ecosystem is also used to generate and send messages to ships and boats using the traditional means of navigation warnings such as AIS, Navtex, and voice messages. Mariners receive these alerts directly through virtual aids to navigation on their bridge systems, VHF and Navtex, as well as through the new Ocean 4D SAD and the Ocean Reporting app, designed to address the needs of the professional and smaller boat users. For longer-term planning, Ocean makes use of species distribution models which highlight areas of potential whale activity on these instruments, enabling mariners to make proactive adjustments and avoid high-risk zones. For example, a cargo ship approaching the area can be warned of high whale density before approaching, and the near real-time warnings received subsequently can be used to support their company's policy to have the crew reduce speed to 10 knots, ensuring the safety of both the vessel and the marine mammals. At the same time, a sailing boat that spots a whale can report it via the Ocean Reporting app, adding to the data in the ocean ecosystem and keeping it up to date. In this scenario, a fast ferry also encounters a pod of whales and adjusts its route based on updated alerts, mitigating risk directly, while the ENHI continuously ensures all this information is shared accurately and promptly. Every year, it is estimated that thousands of whales are injured or killed by vessel strikes. These endangered species share the oceans with us, and it's our shared responsibility to protect them. The Ocean Project offers powerful, real-time solutions that combine satellite detection, acoustic monitoring, crowdsourced data, and predictive modeling to reduce these incidents. This isn't just about saving whales. It's about improving safety for everyone at sea. By reducing delays in hazard reporting and providing accurate and actionable information, the ocean system minimizes risks and ensures coordinated responses. Learn how to integrate the Ocean Project's tools into your existing infrastructure. Contact the University of Western Norway today and join the movement for safer seas and sustainable navigation. Together, we're creating a future where vessels and marine life coexist in harmony.
So thank you to our production team. I think that's a great intro to what we're going to discuss in today's panel. The main focus being collecting data about the presence of marine mammals and sharing that with the world and all the mariners in the world. So, as I said, the focus is marine mammals. And I'd like to start with you, Rui, if I can. The video explains what we're trying to achieve, but why is this important? Why are marine mammals important to notify to mariners? What's the motivation here?
Okay, I think that I could start saying that the main motivation is because we like very hard challenges. But actually, as you've seen in the video, this is a complex problem, but it's a huge problem. Thousands of whales are injured or die every year from ship strikes. So much so that the EU is putting money in trying to tackle that issue. And it's putting money not only in one project, but several projects, several different projects looking at different perspectives and solutions. What we tried, and it's mentioned in the video from the ocean perspective, was to actually focus on systems that are not inboard, but off the ship, and bring information about the presence or probability of presence of animals in an actionable way, so that the crews and the companies can actually plan their trips, plan their routes, and also have information arriving at them at an actionable time, so they can take action, not reaction. They're not reacting at the last moment. They are actually having time to think about their action and their next action when they receive the information from their the data ecosystem that was built in Ocean. And that is also important for the industry. It's not only for the animals, because of course I know that there is no mariner that I know that wants to cause any harm to the animals. They want to navigate in a safe manner, and they don't. I don't think that anyone wants to see a picture like that one that is upstairs, and I think that all of you have seen right now. But it's a whale that has been hit by a large ship, has been cut into slices, and died from bleeding within hours. No one wants to do that. And giving the mariners and the companies the tools to avoid that is what we aim at the Ocean Project. So that is our main motivation, is actually giving the mariners the tools to actually be even better at what they do, also in relation to ship strikes to whales.
That's great, Rui. Thank you. That sets a good context for why we're here today discussing this topic. Also, I'd like to take the chance to mention the training videos that we have online, which, along with the data, we're going to try to provide to mariners there. So a particular training video called Avoiding Ship Whale Strikes, which sets out 4 or 5 best practices for mariners to follow. One of those best practices, Simon, is about reporting when they see marine mammals. So could you tell us a little bit now about, if I see a marine mammal at sea or near the coastline, how can I report that? How can we harness that crowdsourced information and spread that around the world?
Thank you, Brian. Well, at any time, there are between 50 and 100,000 vessels at sea, and that doesn't include recreational crafts. So these really are our eyes on the water. So through the Ocean Project, we built an app that attempts to empower mariners to report potential shipping hazards, be them whales or be them shipping containers. And reporting is very easy. It's literally 6 strikes, 6 fields to fill in on the app. And it really doesn't matter if you don't know what the species is. Is it a whale? Is it a container? Is it dead or alive? How many and where is it? So it should be very simple to report at these hazards without having the kind of the confidence to know exactly what you're looking at. We used innovative technology. We used a system called Progressive Web Application, and this is new, and this enables the app to work on a range of devices and a range of operating systems. So that was a new innovation we brought to the project. Sightings are then sent to the ENHI, or Francisco's black box, as we've been called the last 3 years, because we have no idea how it really works as biologists. And it's then visualized from the box back onto the app, not just sightings, but acoustic detections, whales from space, and they appear as ATONs on the app. And then that's beamed into any vessel that has access to that. Could be on a yacht. On your mobile phone, you could be on a 100,000-ton tanker. So this real-time reporting provides up-to-date, valuable information to inform the mariner, and it also helps to validate the detections from the other systems as well. So all around in itself, it contributes to this huge body of information coming in real time to the ship. Thanks, Brian.
Thanks, Simon. Just to anticipate the question that I'm sure everyone wants to know the answer to, yes, they are whales on Simon's shirt certainly. So after we've moved past the crowdsourcing and the live reporting from the apps, we've studied and researched much wider scale, more technological methods to identify where marine mammals might be. So I'm going to turn to Harvey and Ludwig now, who will discuss the acoustic and satellite detection systems.
Thank you, Brian. So as you mentioned, whales are extremely elusive, not only to mariners, but also to researchers. To put that in perspective, just in the past 10 years, 2 new species of whales were discovered. This is great for science, but it also tells us that there's still a lot of work that needs to be done in terms of understanding species distribution and exploring the space in which those animals move. What we have been doing in order to understand this better has been to use acoustics and satellite imagery. Acoustics has been around for quite a while, for over 60 years as a tool. At UPC, we've been using it, for example, to study a species of fin whales that were passing by Catalonia, but it so happened that they were silent when passing in the area. And from there, we decided to look at satellite imagery in order to detect them. We've been quite successful with that, and we've encountered very favorable conditions. We are at a really key moment in time to do this type of research. First, you've had a lot of evolution with reusable rocket technology that has provided the resources to send vast constellation of satellites in space. And this has produced a huge amount of data that we now have in order to study whales from space. And then the key is that we have this huge amount of data and we need to be able to analyze it. It's untractable to do it manually, so we need to do it automatically. And we've encountered the latest development in AI in order to do this work. And the progress has been really steady with the Ocean Project. At the very beginning, we started with a few hundreds of detections of marine mammals. And we're now at the end of the project with over 10,000 marine mammal detections globally, which we can find in the Mediterranean, in Brazil, South Africa, in California. And this is by far the largest count of marine mammals in satellite imagery in the world. So still a lot to be done, but great accomplishment in the Ocean Project. We have also deployed the algorithms that we've developed on over 1,250,000 square kilometers of data, which is also by far the largest deployment that was done. And this has allowed us to make really interesting discoveries, such as that a species of southern right whale was actually recolonizing a very remote island in the Southern Ocean. And so we have been working on a paper which demonstrates this recolonization. Also, this is great data for science. So just to put it in a nutshell, we have made a great improvement with Ocean. We've used convolutional neural networks in order to achieve those results, and this is where we are currently. Maybe Harvey would like to talk about the acoustics.
Yep, thanks, Ludwig. What we had as a goal for our project, part of the Ocean project, is to make a system which could do passive acoustic monitoring of whales. Our goal is to make that system as self-contained as possible, meaning that the system on its own should be able to figure out where whales are, range and bearing from the system which does the detection towards the whale itself, and also be able to do all the detection and processing of data on its own, meaning no communications to the cloud or whatever to do fancy server algorithms there in some kind of Amazon cloud. So to build that, we thought
it would be good to just start with the basics, make sure that we got a couple of hydrophones down there. The hydrophones were placed on an array, so we got like a hydrophone array. The hydrophone array was then mounted with a cable, a long cable 50 meters below the sea surface. But that also meant we need to understand actually how the orientation of the array is compared to the rest of the world. So there should be a motion sensor attached to it also. So that part of the technology was implemented, which meant that we could focus more on the processing of all the data the hydrophone arrays and the motion sensor would deliver to us. We have built a computer system for that, which is very tiny. It should fit in a small watertight bottle in that sense, which would be placed in a buoy. And in that bottle, there should be an analog digital converter, which makes the raw hydrophone data into digital signals. There was a battery, because the system should run as long as possible. Battery is solar fed, so there were solar panels attached to it. Of course, we do want to geo-reference the location of the detections if we know the range and the bearing from our system to where the whales were spotted. So there was a GPS sensor attached to it, and all that would then be communicating to the cloud just for sending out information. So no data streams of audio. Everything was contained in the buoy itself, the processing system. Only detection information was sent to the cloud with a, for this project's 4G connection. If we talk a bit about what's in the software which was in the buoy developed, there were a couple of parts. The big part is a machine learning system which was able to detect if the sound which we were recording was actually of sperm whales. We got like great collaboration with the team from Roy and the team from Ludwig to make sure we understand exactly how sperm whales communicate, so we could listen in and figure out if we hear them also. Also to make sure that we do hear which might not be sperm whale, we can filter it out in a proper way. What we have then done is made a trigger system, because that listening system shouldn't be running constantly. It just drains the battery very quickly. So there is a lightweight trigger system built, which would be able to wake the more heavy system, the system which does the actual machine learning calculations. And when that when the trigger system is detecting anything, it will wake up a system which will listen to all the sounds around it. We will make some kind of heat map or sound map, 3-dimensional, 360 degrees around us in a spheric layout, and figure out where the most sounds come from. And then we activate beamformers. Beamformers are particular channels of sound we can listen to while silencing all the rest. And with the beamformers, we can actually go into the measurement of how far is the whale away from us and where is it compared to ourselves. And that is then available for sending up to the cloud. In the cloud, we have built a small system, not a big machine learning system, but a small system which would collect information from 1 or 2 or more buoys. And the more buoys it will get, the more certain it can be that a whale has been spotted and that whale is indeed a whale and not maybe a fluke in the system. So fusion of data was happening in the cloud. And when that system then decides with probabilities what the machine learning system would deliver, well, we are sure there's a whale spotted at that distance and that bearing. It would then be sent to the bigger ocean infrastructure for forwarding, as an example to what you've seen earlier this morning, the 4SAD system from Kongsberg. I think that concludes it in a nutshell, Brian.
Okay, thanks, Rui. Did you want to briefly comment there?
Yes, actually, if I can add something to that, is that this morning we had an incredible and very interesting intervention by Mr. Ball, and one of the things that he referred was that satellite images need to have very good resolution to be able to actually detect the animals, and we totally agree with that. And that made satellite images not very appropriate for detecting whale, for these, not for detecting whales, but for this application of detecting whales to avoid ship strikes. But actually, as we have in the scheme that you can see behind us, I hope. We have thought about one thing that he mentioned, that is calling the satellite images on demand, for on-demand monitoring when there is an issue. But at the same time, you have problem areas that are very conscripted, are well known, such in this example, the Strait of Gibraltar, where we have the combination of very high traffic with presence of animals. And those areas are areas that can be monitored continuously by a system such as automated satellite images, detection on satellite images, or it can also be argued that you will not equip the whole ocean with acoustic detectors, but on those problematic areas, if you have an array of those detectors, then you will also receive information from these acoustic detectors. So that is the scalable and multi-layered set that we have here in the ocean, that we have developed for ocean, is getting all this information in different for different conditions in different applications, and then receiving them in the system.
Excellent, thanks, Rui. So finally, it's very clear that we have a lot of rich data here coming from different sources: mariners, crowdsourced, satellites, acoustic detection. So what are we going to do with it? So we need to send it somewhere and arrange for it to be promulgated to mariners around the world. So Francisco, can you tell us a little bit, please, about the European Navigational Hazard Infrastructure and how that works?
Yeah, sure. The infrastructure, which is internally also known as Magic Box, is basically our software running somewhere in the internet, which has many interesting capabilities. But when it comes to the data collection, when it comes to the end-to-end data flow from the different data sources to the consumers, the mariners or ships, what I can say is that we have standardized the way we are collecting the data. We have defined a single interface, a single entry point to receive the data. That means that it doesn't matter if the information comes from prediction models or it's being sent from the reporting app, or even if it comes from detections from the hydrophones or after analyzing satellite images. So we can say that the infrastructure is technology agnostic. After that, once we receive the information, we execute some check-ins to ensure data consistency. And also, it may happen that different data sources are trying to report the same hazard. So we are also controlling these duplicates based on a geographical area and time interval. So in that case, we also can say that we are implementing mechanisms to avoid inaccuracy of the data. Finally, after that, which only takes a few milliseconds, the data is automatically available to generate navigational warnings. And the most interesting thing here is that we allow complex requests for navigational warnings, in the sense that we can be requested to by object type, or within a time interval, or for a specific geographical location, or even combining all these parameters. And even more, we know that not all ships are or have the proper equipment to display some, for example, polygons. So in that case, we also implement the possibility of sending the data translated to single points in order to reach a wide range of ships. That's basically how the infrastructure works.
Thanks, Rui. I have to say, as a mariner, I find this all quite exciting, that we're going to be able to collect all this data from different sources put it all together in what Simon likes to refer to as the magic box and send it out on a live basis all around the world. It's really, really exciting stuff. So we've discussed why we're doing what we're doing, what we've done and how we're doing it. So I'll just quickly turn to Ericsson to see if we have any online questions.
Hello. Yes, there's one. So with the sea speed, with so many ships, can the boys still hear the whales with over all these traffic?
Harvey, I think that's one for you.
Thanks, Ericsson. Yeah, I think that's a very fair question, a very good question also. How do we distinct whale sounds in the vast amount of noise we hear when we would listen ourselves in the water also? Well, the good thing is there are a couple of technologies readily available. We don't need to invent them ourselves. These are called digital filters. We can do statistical signal analysis utilizing digital filters to filter out everything which is maybe below a certain threshold or above a certain threshold. We know where specific species would be in the sound spectrum, what kind of frequency they would emit, and we can filter these out or suppress others to make sure that the ones we want to have are more apparently hearable, audible. And the other option would definitely be utilization of machine learning systems. Machine learning systems are in principle very complex filters, much more complex than we can make them ourselves doing regular statistical signal analysis setups. And machine learning systems will definitely be able to filter out everything we want to hear. Of course, it does mean we need to train these systems a lot. So enormous amounts of data need to be available to make sure that the machine learning filters can do what we expect them to do. But there are very well-known means to make sure that we hear what we want to hear and we can suppress what we don't want to hear when we want to listen to sea mammals. We've tested that ourselves also in oceans with the sperm whales. We've tested that with dolphins, which are completely different frequency spectrum than the sperm whales we were testing with. And for both of these, that worked pretty fine. Right.
Thanks, Harry, for the thorough answer. So I think we might just open to the floor and see if we have any questions in the room. I'd like to ask the panel.
Yeah. Yes, thank you for opportunity to be here because this is the whale reporting is the biggest reason for me to be here because when I saw her at the SSR, I was really, really happy about that because we are also developing similar kind of systems which uses more AI. So that means, is there any chances for a company like our companies to contribute as a crowdsourcer and contribute as a distributor? That means if we can have some API to the infrastructure to provide the whales our users identified, and also if we can source that data to disseminate such important information to our users, I think that can extend impact or effect of this kind of service or technology. So I'd like to ask you that if there is such kind of a technical matters, and also I don't know who can answer, but if there is that can be considered to share such kind of APIs to the other stakeholder or other entities like my company or other companies.
Thank you for your question. I think I'll add to that, Francisco. Maybe you might take this one. The main question is, all the technology that you developed and the infrastructure, what happens to that now as ocean comes to an end?
Okay, the first I can say is that after the end of the project, the infrastructure will keep running for I hope a long time, but it's true that these kind of opportunities are very well for us because we are implementing interfaces that are open to everyone who wants to contribute. Also, we are willing to create like a system of systems solution for mariners and for ships. So integrating with other similar systems, it's a good potential for us and for other systems. Our interfaces are open, so you only have to register the system, which is easy and free. And then you can interact with us, just send information. Of course, if you want to get the information that we are collecting, you can use the interface also that we have open for free to request the navigation or the data that you can use to generate navigational warnings. So the conclusion is everything is free to use, and everybody can join and join the ocean ecosystem.
Thanks, Francisco. I think it's one of the main points with Ocean. All this development and technology and research is freely available for others to take on and use in the future. I think we have time for one more question from the floor, maybe. I think I had a question.
Very interesting panel. Thank you very much. I have just curiosities. Firstly, in the video you talked about models of spatial distribution of the animals. No? So if you have, if you can predict where the animals are, where do you need the other things you have said? And secondly, I wonder if your detection models can distinguish different species.
Thank you. So maybe Rui, Simon, can you talk about the predictive models, and then we'll come to Harvey and Ludwig on the differentiation of species. We have just a few minutes left. Please give me brief.
Okay, briefly. So let me give you an example. So we are talking about models. It's the same as a weather model. So if you have prediction of rain, 80% of probability of rain tomorrow, you will dress accordingly for rain. But it might not be true. The prediction may be wrong. So the models cannot solve the problem by themselves. They are just a tool to actually to help in planning the voyages. Something, Simon?
Yeah, I think it's important to remember that things are changing as well. You know, whale populations are increasing, whale distributions are changing. So we need to be vigilant that where whales may not have occurred in one area, they could possibly in the next 5, 10, 15 years. And where there isn't a ship strike risk at the moment, there might be in the future. So I think the Ocean project is quite robust and future-proof to be able to adapt to those changing environments that we're living in.
Thanks. And Harvey and or Ludwig, just very quickly, do your systems differentiate between species?
Yes, so that's been one of the main tasks of our system, was to classify between different species. And we go from the most difficult species, which would be, for example, the humpback whales, which tend to have a lot of movement and are difficult to identify, with the easiest species, which would be the gray whale. And right now we are differentiating between 6 different species, and we have a recall which is around 77% for the most difficult, and around 97% for the highest rate of recognition. And to do that, basically, we've used our database of observation, which I mentioned, from all around the world, basically. And we basically know, as you were mentioning, that the whales congregate in certain areas at certain moment of the years. So we looked, for example, at Western Australia in the month of February. We looked at a ton of data in Mexico in January and February and so on. So we really looked globally at satellite data in order to build this database and then train our neural network to get this accuracy.
Okay, gents, that's us. We are out of time. Harvey, you're off the hook. So just to quickly sum up what we've discussed in the last 40 minutes. First, how we can collect data, both on a live crowdsourcing manner through the reporting app, and also through longer term technological solutions such as the satellite detection and the acoustic detection systems. And then we discussed how we can gather that into the ENHI ready for rapid promulgation to mariners all over the world. Thanks very much.
Oh, thank you, Brian. I think it shows that you are working in a ferry line with this level of precision. I mean, I guess the boats are running exactly as precise as this.
Always, Eric.
I knew that. Thank you very much for moderating this panel. I think it went very well. I hope that it was informative. I understand that we will now bring London online, which would be great. Maybe. People are sweating in the control room, I can tell you right now. So, and meanwhile, maybe we can prepare for the next panel. So this morning you heard about containers and whales, and now we have been drilling into the detection and distribution of information from whales. I think we should invite our guest speakers here. You fix that. Yeah, that's good. Good. So the moment that London is online, then we will continue. We are now looking at the container bit, like I said, and this session is a little bit different because we will show you the video about lost containers. Richard will tell us, you are working with the Norwegian Coastal Administration to introduce you. And Richard will tell about the perspective seen from a coastal administration, from a coastal state that is responsible for their waters and hence are responsible to pick up things that fall into the water, including containers. So you will give us your view on that. And then there will be a panel, I wouldn't say discussion, but I hope a conversation where we'll bring in the views of IMSA. Is that correct? Very good. Are we... No, I think we will just continue. So, Richard, over to you, but I guess we will run the video first.
We will start off by showing the video. So when they are ready in the room, we will. Oh.
Accidents and incidents at sea don't happen because seafarers lack skill, but due to a combination of risks, some that mariners might
not realize exist, others that they can't avoid in time. Imagine a day when navigation is significantly safer thanks to systems that provide enhanced situational awareness. This vision is becoming a reality through the Ocean project. Let's explore how it works in practice. Although this case study is a simulation, it's based on real processes and systems developed within the Ocean project, all of which have reached technological readiness level 7. These tools are poised to address challenges recognized by stakeholders globally, including organizations, coastal and flag states, and by the International Maritime Organization. One of those issues is the loss of containers at sea. It's not uncommon for containers to fall off ships, creating hazards for vessels and marine life, just like it happened in this demonstration on a morning off the coast of Norway. The container ship MV Global Navigator encountered a large wave, causing 6 containers to be lost overboard. Following standard procedures, the officers promptly issued a security call on Channel 16, notifying nearby vessels and reporting the incident to coastal authorities and the flag state. With new procedures in place due to the Ocean project, the situation was reported by the Norwegian Coastal Administration to ships within radio range within minutes. Warnings were sent to vessels via the established means of enhanced group calls, VHF and AIS, and directly displayed as virtual aids to navigation on their ECDIS systems. Importantly, the Norwegian Coastal Administration also utilised the European Navigational Hazard Infrastructure, or ENHI, through the online platform developed by the Ocean Project. The ENHI was then able to issue similar warnings to connected mariners in near real time, immediately showing up on the connected systems developed by the Ocean Project, the 4D SAD and the Ocean Reporting app. Either system provides much more detailed information to watchkeepers compared to current facilities, and the ocean ecosystem is thus capable of reducing the current 4-hour-long lag of traditional navigation warnings, like Navtex and regular nav warnings. Following up on the initial warnings, satellite imagery requested by ENHI was analysed to locate the drifting containers as soon as it became available, and the open drift model calculated their probable paths. Updating and transmitting this updated information in a timely manner kept the seafarers informed and safer than ever before. As weather conditions improved, a second ship, the Wave Convincer, entered the area fully aware of the floating hazards in its vicinity, thanks again to Ocean's 4D situational awareness display. Adjusting its route, the vessel successfully avoided the area where drifting containers were most likely to be found. Using crowdsourcing, a ship equipped with the Ocean Reporting app, which displays hazards and simplifies reporting, shared a sighting of a container and received continuous notifications about additional sightings, enhancing both the system's accuracy and the safety of the reporting ship. Simultaneously, salvage operators were alerted, and a recovery plan was initiated by local maritime authorities to mitigate possible environmental impacts, with the ENHI continuously monitoring and updating all seafarers and stakeholders about the situation. All of these ocean system tools, including ENHI, 4D SAD, and the Ocean Reporting app, are more than just new technologies. They're practical solutions addressing real maritime challenges. By significantly reducing delays in communication, the system ensures that vital information reaches those who need it most, improving safety for vessels and the environment alike. Whether it's detecting whales, identifying drifting containers, or issuing rapid navigation warnings, the ocean system enhances situational awareness with unparalleled speed and precision. These tools seamlessly integrate into existing frameworks, making adoption straightforward and cost-effective for the maritime industry. If you're ready to enhance maritime safety and environmental protection, contact the University of Western Norway to learn how ocean tools can integrate into your existing infrastructure. Let's build a future of safer, smarter, and more sustainable navigation, one step at a time.
That was the video. And now I can see London is online. So should they say anything or just wave, Ali? Well, I'll go on. I have a quite bold statement here. That is the Norwegian Coastal Administration vision. And that is to make Norwegian coast and sea areas to the safest and the cleanest in the world. Keep in mind that we are the second longest coastline in the world. So it's not an easy task. It's not something to be taken lightly upon. To keep it safe, keep it clean, we need to do something. So here is one of the questions that we tried to find solutions for in this project. Where are the lost containers? This is a heat map of vessel traffic based on AIS, in cooperation with EMSA, by the way, where we can say there is vessels going here, and we can say something about what kinds of vessels are going there. But we don't know when they lose their containers based on this picture. So we did some research and we tried to find out what are the conditions that we need to be aware of and how can we minimize the risks of losing those containers. So that's when we started doing something proactive. And we look into issuing proactive navigational warnings to ships in areas with risk of losing of container loss, because we have discovered there are areas where the risks are higher than others. And if we can make the mariners aware of that risk and make them take precautions before they go into that area, we can perhaps prevent them from losing some containers. And that could be something that we can get some positive feedback on. And then in real time, we will try to broadcast the warnings for the drifting containers to nearby vessels, to the areas, to ensure that they are aware of that there are drifting containers that might influence your vessel if you hit them. And hitting a container on many gross tonnage will make some harm. And then for the future, we are providing drift forecasts and integrate the ENHI and NCS systems where we say that there is discovered containers in this area, and it's likely that they are drifting to that area. And if they, well, of course, the drifting model gets a bit rough after a little while, so you need to update the drifting model. But if you have more sightings, you will have a more clearer view on where the containers are going. So it will be easier to avoid them or to find them to pick them up. Because that's also something. I would not like all the containers to sink to the bottom of the sea and pollute everything. I would like to get them away from the sea. And also in the future, based on this project, there will be an inf paper sent to IMO on loss of containers and some solutions on how to deal with them. And then there is this AI thing that we have been speaking about earlier today. AI is something that we will use for everything, I guess. But let's make some sense of it and figure out where is it sensible to use AI. And one of the things is how can we find missing containers? So Ludwig did an excellent job in his task with recognizing containers on satellite photos. What we also started to look at, but we haven't completed, is looking at the QR code on the picture, on the barcode of the vessels. When a vessel goes from port, there is specific color patterns on the deck for what containers are on board. And when it comes to New Harbor, it should be the same pattern. They shouldn't move around the containers while they're at sea. So if it has changed, it's likely that they have lost something. And that's something that we could look into. And maybe we can use that information to point the satellites and take photos of the areas where the vessel have been sailing to discover the floating containers. But still, we remain on guard for maritime safety. We are trying to avoid vessels hitting something going around. But if they hit something, if there's an accident, we will be there to help them solve that problem. If they spill something, we will try to get that spill up and we will try to make the environment safer and cleaner for everyone. And by that, I would like to invite my two colleagues from EMSA, Lucas and Marta. And I will actually go and sit down and speak with them. So bear with me. Both Lucas and Marta will do a short introduction of themselves. But I think we will start with Marta, and she can tell us a bit about legislation work that she's doing within EMSA.
So hello, good afternoon everyone. So I would like to welcome you to EMSA. It has been a pleasure to follow your closing event meeting during the day. So I started in the morning at last row, but it was quite interesting, all the discussions. My name is Marta Lima. I work for EMSA for quite a long time. I've been here working for 19 years already in several projects. And currently I am a service manager for one of the first maritime applications that EMSA has developed, which is SafeSeaNet. So SafeSeaNet is a system that was built together with the member states, for the member states and with the support of Commission, to exchange information between member state authorities. And then later on, I'm going to further explain to you how this system also exchanges information on lost and found containers reported by the authorities and by the ships to the coastal stations. But I will now pass the floor to my colleague Lucas.
Thank you, Marta. So my name is Łukasz Żukowski. Also quite a long journey here in EMSA, a bit less than Marta, 15 years. Yeah, it's very interesting to be here on this final conference. For me also, what I enjoy very much, and I discussed already during coffee breaks with many of you, that you manage to gather people from different communities. So even for me, for a person who, let's say, was wearing a different hat during the career, because I started as a sailor, then working in VTS, then move a bit more to the project management. But it's actually, you can only achieve results when working together. So I think this is a big success of your project. So yes, we are very happy to be here and to contribute to this panel on the containers lost overboard. So I think now I will pass the floor back to Marta to tell you a bit about the current legislation in the European Union when it comes to the containers.
Going back to the SafeSeaNet system. So SafeSeaNet is a system that exchanges information between the member states' national systems. And I do work very closely with a colleague of Richard, with Harold from the Norwegian Coastal Administration. So in each member state, they have a national system that collects the information. So in Norway, it's called SafeSea Norway. SafeSeaNet Norway. And this system collects information reported by the ship to the coastal stations, and also before the arrival of the ship to each port, the information reported by the agent representing the ship with all the reporting formalities that the ship has to do. And then some part of this information is exchanged. Going more in detail in the lost and found containers, so there is an obligation for the ship and for the coastal authorities to report this information, as this is a hazard to navigation. So what the ship has to do is that if the ship has lost any container or has observed any floating container, the ship has this obligation to report to the coastal station. And then the coastal station should use this information to warn all the other authorities that are in the vicinity and likely to be affected. So this is how SafeSeaNet plays here a role, and how we see that this project could perhaps bring here some added value. But now I'll pass the floor to my colleague Lucas, who will bring some more practical information.
Yes, thank you, Marta. So indeed, there is a clear obligation to ship masters, but also to the coastal station to share the information. And our role in EMSA here, it was actually to establish a system, establish a network that is for member states to be able to exchange data about different incidents or accidents. Lost and found containers is one of them. Here, actually, I saw in your presentation that you mentioned that IMO will be informed through an INF paper, and we have followed recently the subcommittee on the carriage of cargo and containers, and there were some also outcome of this meeting, which I believe they are going very much in line with your project. And this was that they found actually that the recent changes that will be introduced to the SOLAS Convention obliges reporting of lost containers from shipmasters, from the ships in vicinity, from flag states towards IMO. They even created a form where this data is being reported. So again, thinking about synergies, maybe the application you have developed, this is something that could be somehow integrated and like this, avoiding double reporting. Because again, I think at the last IMO meeting, when it comes to double reporting, they found recently that what they have proposed, and it's actually approved for SOLAS Chapter 5, I think it will enter into force from 1st January 2026. It's a bit double reporting when it comes to this Nairobi Convention. So again, I think it will go to leg at IMO, but so your project, I think, comes in a perfect time, and the more we integrate data, and it was also mentioned by Lendert in the morning that we in EMSA, we are looking really for new sources of information, because more data we have, the more clever we are. And it was also mentioned that, of course, not all of the data can be processed by human brains, and that's why we are using different computing powers to do it. You mentioned several times during the conference today artificial intelligence, which is more and more used to support human work. So yes, coming back to the topic, indeed, this reporting, there is also certain freedom, let's say, at member states level, at country level for the coastal station, because from the system point of view, from the central system point of view, as Marta mentioned, we provide a network. And what we actually agree with member states is how the data is coming from one country and it's shared with the others. But your project, it's more about how the data is sent from, let's say, from the ship, from who observes it at the sea, to the coastal station. So this part is somehow not controlled, and I think this is kind of a place where your application, your developments could play a role and could simplify and speed up the processes. Because of course, still the reporting via NAVTEX, which I saw already also in the exhibition that you are showing, that this data is being spread, but also further the obligation that the member states have in accordance with the legislation in EU, that could be further elaborated, and that definitely there are many synergies there.
Yes, there is a lot of synergies, and we are doing similar things in many systems and in many ways. But what I think we can start doing is ease the burdens of the sailors, make it easier for them to report, and that's something that we really should strive for. Make them report it once, not twice or three times. Make the report valid, so they make it easy for them to do it. And then I think the percentage of reporting will go up when we make it better for them to report. So I don't know how we can do it with your systems and this system, but as Francisco said, there is open APIs. We can ship those data from a system to another system, so we can share our data all over. And I think that's one of the advantages with the ocean.
Yeah. Any questions from the audience for any one of us? I see there's a couple of hands in London. How you used my glasses today?
Hello, greetings from London, everyone. My name is Dr. Muhab Abul Qawam. I'm a master mariner by background, assistant professor in Liverpool John Moores University, and I'm a consultant. I am very interested in the element of maritime safety and what we are talking about today regarding the loss of containers at sea. Of course, as we already know, that when we lose containers at sea, it is obligatory, of course, to report by the captain, but there are some caveats here. Question one, did they see the container being lost in heavy weather or lack of proper lashing, or they wake up the next morning, the morning light, and they discover that during last night's heavy weather, some containers have been lost? And then they will report, but of course, they don't know exactly where the containers are lost. They will have to report their course and speed and geographic locations during the last 6-7 hours. But again, this is linked to the meteorological data. So do we have, the question clearly, do we have we are assuming that, of course, everyone receiving a report will try to calculate that if a container is lost here, the prevailing winds and currents, oceanic currents or tidal streams, if it is a coastal area, will lead the containers towards this probably sensitive area or maritime route. So is there an intention to link this good project to real-time meteorological data, so that the reporting can also give a trajectory of movement of those supposedly floating containers on the ocean, and warn the mariners more realistically in an area which is the containers would most probably have drifted to? Thank you very much.
Thank you for your question. I will try to answer it. It was a really good one, so I'm not sure I will be able to answer it. But we have created some drifting models, and they are based on live data. That drifting model will, of course, be more accurate for where the containers are going if you know where you have them as a starting point. So if your starting point is an 8-hour window of sailing in heavy weather, it's not very easy to pinpoint where the containers are. But there is created some algorithms to try to figure it out. But I wouldn't guarantee that it's 100% accurate at all times. Any other questions? There is one.
May I add something to your answer? Just in the door of this room, there is a poster where you can see the diagram of the ocean data ecosystem. And there are two components that we have not mentioned. Well, one of them, yes, it's the satellite imagery analysis. The other one is the container drift prediction that you have mentioned. This is an on-demand component that we can use. We can configure the infrastructure to request a simulation for the next 48 hours. So if we know the location of the container when it has been lost, we can request this prediction for the next 2 days. And this is integrated as more information that can be retrieved from the infrastructure. So yes, we are integrating weather forecasting, let's say, because the open drift model that we are using to predict the container drifting is interacting with this weather prediction. So the answer is yes, we are integrating this information through the container drift prediction.
And I just yeah, just sorry, just to add also to this, because how also the system that we are, let's say, administrating and managing here in EMSA, the SafeSynet system. So one of the main objectives of this system is also this awareness of about situation that is happening. So if you think about lost container in the project, you are very much focused on the safety of the ships which are navigating in certain area and may eventually collide with such a container. But also when we think about this aspect and about our system, we are also very much concerned about environment, because you never know what is in the container. Quite often it may happen that there are dangerous, hazardous substances. So that's why the SafeSynet system that we have, like Marta presented to you, there is this important element of an early warning. So, and for this purpose, the different member states, they are using different drifting models. And if there is any risk that the container is or may be drifting to an area of another country, so then suddenly it may affect other country, they are informing each other. And more different technologies are being used for, let's say, monitoring. So in the past, there were normally aircrafts, but more and more the network of drones or the AirPass services is being used to follow up. So this is also something that is being done. When it comes to satellite images, I think Lendert mentioned in the morning, if you know exactly the areas, they are very efficient and they can help. If you look for a bigger area, that's very expensive and not that much efficient.
Yeah, maybe I would like to add to that. You took half of my statement, which was about using the satellite images, because this is one, I think one of the stronger points I see in ocean, that we have more than one tool. So in Richard's example of 8 hours of heavy weather during the night and you realize you lost something, if the visibility was good, then you could actually bring in satellite, but you have mentioned that. I think the other thing you said about reporting is extremely, it's very important that we make it easy to report. And one of the things I personally see as an asset in ocean is that we are bringing in a much larger recording base. It's not just solar ships. The app is freely available. It can run on any device. As long as you have some kind of internet connectivity, you can report. And that means that you could say the likelihood of somebody else seeing those drifting containers is increasing exponentially as we add a much larger potential user base. And that is one of the things where I see a possible, probable synergy between what you are doing and what comes out of the ocean projects, to try to, you would say, to use that as a leverage to get a much higher density of data into the systems. So, but that was not a question, that was a statement. Thank you very much.
Let me, sorry, Eric, let me just add one thing about the reporting. You can report at any time. You don't need to have internet connectivity. As long as you have the internet connectivity, the app will sense that and send a message. So even if it's a few hours delayed, once you get internet connectivity, it is stored in the system that you're using, a tablet and a cell phone, and then it's going to be relayed. So.
Just to mention that following your remark, this is a quite important requirement. We do have a similar maritime application that EMSA is developing for reporting of ship to shore. And we are aware that sometimes the ships, when they want to report, they don't have bandwidth. But it is important that we record the information. We record the position where the accident took place, because that's the most important part then to run the drift models. So that's a very, very important requirement.
If there's any other questions, we will do that. We have a few minutes left. If not, I think I should say thank you to Marta and Lucas.
It seems there is one.
Oh, there is one.
Yeah.
Yeah. There is one question.
Thank you. It's just some more comments, and for the prediction of the floating containers, there was when I was in the research institute, there was some project that developed the predictions of the spill oil spill, and also man overboard prediction. So in this case, I found that there is accumulation of errors according to the time. That's why I believe, Richard, you are so a little bit careful in saying that we can predict the position of the container. So I like to say that is not just a linear problem. That is a huge accumulation of errors according to time. So that means we can just show there's an area of high probability, not exact position. That's very important for the users to use that information. So I suppose the areas should be given. Also, that means to check that wide area. I think the synthetic aperture radar or some kind of very sensitive on that kind of material like a container can be used for more efficiently, I believe. Thank you.
Thank you. I think I would like to respond to that. We're fully aware of this, and if you remember, Francisco spoke about earlier that we are sending out polygons for warning. So the OpenDrift model, for instance, has a cone of uncertainty, and we are using that, and we are sending out an ever increasing area. And this is one of the hard things that for how long do we dare depend on the model prediction? And if you don't have a sighting within a relatively short time frame, then it's either sunk or it didn't fall off where it didn't, or the model is not correct. So we will remove that again. So we maintain the data, and we maintain the you could say the likelihood of those data being correct. And if we figure out that they are not correct, then they are removed, and that happens instantaneously across all connected users. So but thank you. It's a good comment, and there's no certainty in this. Yeah. Thank you very much. A little thing to bring back. Thank you very much. Thank you for your intervention. Thank you. Good night. So with 1.5 minutes ahead of schedule, which is really nice. This will take us to the last presentation of the day, or the last group panel of today. And the question might be, now you have heard about all these things that the project has produced, and the big question becomes, then what? So how are we going to move forward? What will it take? What will it take for somebody to adopt results or part of the results from Ocean? And this is what we call a roadmap to implementation. And David, you are moderating this team, so please come up here. And I assume you want the panel to be here as well? Yes?
Oh, you can do the first thought. No?
Yeah, I got it. Wakey wasting. It's technology.
Yes. Cutting edge.
So on the other, to introduce the other panels, you saw this infographic, and we thought this was not meaningful maybe for this panel. So here's another infographic that is about get safer at sea, and this is how we see ocean can contribute. So you will come to hear that this can be grown from the bottom up, what we call an ocean microsystem. We will introduce that. And we have also guessed at a timeline. So things take time. Getting traction for microsystems might maybe be a 2026 issue. 2027 might see the ENHI as a fixed European service that is to the benefit of everybody. And we might see plans to have full-blown ocean systems, meaning that the app is there, the infrastructure is there, hydrophones are deployed, satellite monitoring is available for a particular area. And this will be in areas where you have a really high density of whales. For instance, in an area like the PSSA north of Corsica is a very likely spot in European waters. And there are other hotspots in Europe around the Azores for sperm whales. The North Atlantic right whale along the eastern seaboard of the US is another area where we have a highly endangered species. Only 250 animals are left. And it's bang in the middle of fishing grounds and traffic in and out of Boston. So there is really needs for this kind of thing. So this is what we hope might happen maybe in 2027. And then in maybe 2028, we will see ocean systems as a pan-European service, everything singing and dancing, all up and running. So this is what we're going to discuss now. And Captain Petreko, the floor is yours, or the dais is yours. You want the con, yeah.
Thank you, my friend.
All right, thank you. Welcome, everybody, and particularly welcome those people online and our friends in London. Hello, London. Right. Before I start, I'd just like to introduce the panel. My name is David Petreko, Captain Petreko. I'm the Director of Projects with the Nautical Institute in London. I would like to introduce the panel. So we'll start with Treya Heaps, who's the IT Administrator of the Irish Whales and Dolphin Group. Treya, wave, everybody. And she's been in the lead on the reporting app that you've heard about. Francesco, who you've met in other panels, is the informatics engineer and intelligent transport system project manager at the International Center for Numerical Methods in Engineering. That must be nice to put on a business card. Harvey, who's no stranger to these panels, he's the site lead at Teledyne, the Reason and R&D director for Teledyne Maritime. Dr. Jonathan Earthy, the principal human factors coordinator and technical directorate at Lloyd's Register, and Georgia Zamara, who's the researcher from the National Technical University of Athens, NTUA, with a background in physics and engineering. And she's the genius behind where all this is going to end up. So welcome, panel. We'll watch a little bit of a video. This is the
trying to pull all the pieces together. So we've talked a little bit about the different pieces today. This is going to try to bring it all together. So if we could watch the video, please.
For seafarers in European waters and all around the world, being aware of what hazards lie ahead on their journey is paramount. With individual ship sizes and the volume of maritime traffic only increasing, navigating through congested waters safely is an ever-increasing challenge. Seafarers are great at what they do, and the industry's safety record is excellent, yet accidents can still happen. We can continue improving to keep
our mariners, ships, cargo, and the environment increasingly safe, as well as contribute to the conservation of marine megafauna on a much higher scale. With the Ocean Project, there's an already proven set of solutions that can do just that. The European Union and the United Kingdom have joined forces to fund the Ocean Project, a groundbreaking data ecosystem designed to improve overall navigational safety while protecting marine life. Every year, undesired navigational incidents and collisions between ships and marine wildlife, especially whales, cause irreparable damage to nature and jeopardize marine mammal conservation efforts. In European waters, this problem is particularly pressing given the dense shipping traffic and the rich biodiversity of some regions. On top of that, containers occasionally fall off ships and remain adrift, often as invisible hazards, posing serious risks to smaller and lightly built vessels, further complicating navigation in busy shipping lanes. That's where the ocean data ecosystem steps in. The Ocean Project is a truly human-centered initiative, developed with seafarers rather than simply on behalf of them. It actively involves seafarers from across the entire maritime spectrum, leisure sailors, fishers, and commercial operators alike, ensuring that their real-world experiences, insights, and needs shape its design and implementation. Let's break it down with a real-life example of a fully developed ocean ecosystem. Imagine a pod of whales spotted in a dense traffic shipping area in European waters. Europe has already identified particularly sensitive sea areas with high concentrations of both marine mammals and maritime traffic. In such areas, hydrophones can detect the presence of underwater mammals, while nearby vessels may report sightings using the Ocean Reporting app or the Ocean Situational Awareness Display 4D SAD. Such data is complemented with AI-based analysis of satellite imagery and combined with predictive models that forecast areas preferred by marine mammals. If containers have been lost overboard, the ocean solutions include drift modeling to predict risk. All this information flows into the European Navigational Hazard Infrastructure, or ENHI, which has been designed and created by the Ocean Project, and that, in turn, directly shares warnings with the Ocean Reporting app, as well as the 4D Situational Awareness Display. The ENHI also provides information to coastal states to support alerts through Navtex, voice, and virtual aids to navigation via AIS or other communication channels already available on ships. All of this information is thus made available to the watchkeepers without added investment. For instance, on the bridge of a nearby cargo ship, the watchkeeper can immediately see an alert and take precautionary measures to avoid whales and any other drifting hazards. By involving coastal states, the ocean solutions integrate seamlessly into instruments seafarers already have available and trust, making it intuitive and effective. The ocean tools are not just mock-ups. They have been developed to reach a technological readiness level of 7, which means they are ready for demonstration in an operational environment. The ocean solutions reach wider than whales or containers. They're about creating a safer and smarter maritime environment. Its modular and scalable design means it can adapt to various needs, whether it's a marine protected area manager looking to safeguard biodiversity, a regulatory body aiming to improve maritime safety, or conservation groups supporting global initiatives like 30 by 30, where the aim is to protect 30% of the oceans by 2030. By providing real-time actionable data, the ocean solutions empower stakeholders to make informed decisions that benefit both the environment and maritime operations. The system's versatility is a key strength. It uses technologically agnostic solutions or pre-existing interfaces, processing data from satellites, hydrophones, apps, and more, and integrates with existing systems like those used and standardized by coastal states and the International Hydrographic Office. This ensures it can work within current frameworks while remaining future-proof for new standards and technologies, such as the S100 series. The ocean system is poised to be an easily deployable and scalable solution. With potentially zero investment, it delivers massive returns. Any local community, stakeholder group, or organization can initiate the use of an ocean microsystem for free by simply adopting the Ocean Reporting app and the European Navigational Hazard Infrastructure. The ocean microsystem requires a very low or even zero initial investment, but is fully scalable. As the minimum viable system, it provides a strong foundation that can be expanded over time. Additional components such as hydrophones, species distribution models, image analysis, and the 4D SAD can be integrated one by one to enhance data collection based on local needs, available funding, and specific conditions. Furthermore, involving the local coastal administration can significantly increase outreach to existing ships and ship systems, paving the way for a fully developed and comprehensive ocean installation. Together, we can create synergy between systems and datasets, making maritime traffic smarter, safer, more sustainable, and more resilient. Implementing the ocean system is a clear step towards safer seas and healthier marine ecosystems. By reducing ship-to-ship collisions, strikes to marine mammals, avoiding hazards like drifting containers, and improving overall navigational safety, the ocean solutions offer a tangible solution for maritime stakeholders. We're inviting everyone, policymakers, conservationists, and industry leaders, to explore how ocean can support their goals. As a minimum viable system, ocean is there for the taking, for free. It's up to you to adopt it and promote it at a local or regional level. Contact the University of Western Norway to learn how ocean tools can integrate into your existing infrastructure.
Right, so I'm very pleased to be here because we're very proud to have been part of this project. We get invited to quite a few projects based on the reputation of the Nautical Institute, but one of the reasons that we got involved in this one was when the consortium contacted us, their root value was that mariners are inherently make good decisions. We're not trying to automate, we're not trying to get rid of it. 80% of accidents are caused by humans, so get rid of the humans. No, it was about the value of human decision making and how better tools and better information could make even better decisions. So that was great. As you heard in the video, one of the other great benefits of the project is it's very modular. It's technology agnostic. So you can grab bits and pieces that fit here and there. It doesn't have to be a one-size-fits-all solution. So there's a huge amount of potential. Now, one of the things that the video showed, and I'm going to ask Treya to elaborate on this, is it talks about a microsystem, which is very easy to implement, has a very low barrier to entry. So Treya, could you just elaborate a little bit about if somebody wanted to implement that microsystem, what would that entail? How would they go about it, please?
Sure, David. You've seen from the video there that the microsystem consists of the hazard infrastructure, which is the ENHI, the infrastructure system, and users of the Ocean mobile reporting app. With these three components, the user can report and view potential shipping hazards, or more specifically, large whales or floating containers. This is the minimal viable system that was referred to. A good practical example then is in the implementation and management of marine space, such as marine protected areas, or MPAs, PSAs, or IMAs. The installation and the usage of the Ocean app could be a condition of a license to operate within or even pass through an MPA, where potential shipping strikes with large animals could occur. For example, in my local area in the west of Ireland, there are certain times of the year where there are large aggregations of basking sharks. often invisible, just below the surface, or breaching spontaneously with absolutely no warning. This area around the mouth of the River Shannon is of global importance for these particular animals, and it's also a busy shipping channel. And for a few weeks of the year, ship or boat collision risk is extremely high. So reporting and presenting sightings to boat users in this area in near real time during this time could be a very valuable tool to protect the boat user and the animal. And maybe having the app installed could be a precondition to enter this area. Finally, as was mentioned, the ocean solution is modular and it's scalable. So if more specific needs arise, for example, in a breeding area, it can then be expanded and enhanced with the buoys or the satellite monitoring.
Sorry, thanks very much, Treya. So Treya's explained about that microsystem and how it's able to expand, and we'll probably get into that a little bit more in the future. But like I said, one of the things that really attracted us to this project was its focus on humans, human needs, and I was thrilled that Dr. Jonathan Earthy, who I've known for many years, was also involved in this project and has contributed so greatly. But Jonathan, as I said, one of the things that the Ocean Project has from the beginning focused on is those user needs, not just a specific group, but all user needs. Can you highlight how the ocean solutions that we are demonstrating today can be useful to all users to improve situational awareness and ultimately improve safety?
Thank you, David. Yeah, it's a multifaceted project, but we have picked up on situational awareness as something that we've investigated deeply in the project. As David said, if we take it as an example and we go around the different stakeholders, we focus today on navigators and providing them with information and understanding what they need and building systems to suit that. But there are other situations on the ship and off the ship where situational awareness is an important concept. If you go down from the bridge into the engine room nowadays, there is an equally complicated situation to try and monitor, not necessarily with such integrated technology, funnily enough. And in that case, using the same conceptual model, the three-step model of understanding what's going on, or seeing what you're being shown by control systems, understanding and then deciding what is actually happening and how to manage that. That's exactly the same thing. So taking the same, but in which case the need is not to see what's going on outside the ship, it's to understand how the platform's behaving, and if it's not behaving properly, get the engines working again, or get some other system operating so that you can maintain headway and safe passage by having a working platform, working engine, working supporting technology. If we move a little bit off the ship, we have lots of different control centers nowadays. We have vessel traffic management. We have for some time had fleet control centers where collections of ships, the whole fleet of a particular company has been monitored and supported, possibly with logistics or financial information. And then we have now the talk of remote operating centers, which can actually take some degree of navigational control. All of those have rather different situational awareness needs because they're doing different things. VTS is offering support, but monitoring an area of sea. The remote operating center is looking at one or more ships, but getting very deeply involved in exactly what they're doing and whether they're performing properly and whether they need help and other communication. And then fleet control is a much bigger picture, but in every case, it is situational awareness with different needs, building off what purpose being there is, all different scales and purposes. So In other words, situational awareness means a different thing for each user, each group of each stakeholder in their context of use and their needs. Now, what do all those have in common? It's an element of control, having meaningful oversight and control, as I mentioned earlier today. Beyond that, there's another dimension to think about is needs. And we have information needs. So we have two examples. The 4D SAD work through carefully, and what we see is design going into understanding exactly what the situation as requires are and designing a system to support that and iterating that until the user can definitely control. We have another very good example in the project, and that is the ENHI itself, which has looked very carefully at the information needs and implemented very precise and carefully developed ways of ensuring that that's right and efficient and simple as possible. And also expandable, because we were concentrating on two things, but we've already talked today about other information that could be put in. And that would include environmentally sensitive zones, etc., as Fresh has pointed out. Stepping back from that, in terms of products related to user needs, in addition to the technology the project has developed, we've also developed some more intellectual products. And a very good example is the additional work that has been done on elaborating the concept of situational awareness with more thinking about how it supports decision making. Well, I think in addition to what we've talked about today, do go and look at the full set of material that is available, the deliverables, because there are lots of intellectual products which actually assist and advise. And even looking at the development life cycle of some of the pieces of work that have been done is a good example of how to develop in an organized fashion, fully understanding the risks you're trying to mitigate. Thank you.
Thanks very much, Jonathan. Jonathan, you mentioned the ENHI again as being the heart of the project. So, Francisco, ENHI is the European Navigation Hazard Infrastructure, otherwise known as Francisco's Magic Black Box, which we've heard. It has been referred to as the glue that holds us together. Can you speculate on how this might be incorporated into future services in Europe or even around the world? And I think I might even have a slide that helps explain that.
Oh, exactly. Thanks, David. I think that glue is a good word to define the role of the ENHI in the ocean data ecosystem. So you are asking about future services in Europe and the world. So let me comment on that. First, I must say that right now the infrastructure is supporting, navigation on safety by means of creating information to generate navigational warnings, and we are doing that using the data that we collect from the sources and using technologies standards and protocols that are very well known by the industry and are widely used. And among these technologies, we are also including a basic and first implementation of the S124 protocol, which is the specific definition for navigational warnings within the S100 series of protocols promoted by the International Hydrographic Organization. So with all of this, I want to say that we are right now supporting navigation safety, but we are also ready to face navigation safety in the future. Before I I mentioned the concept of system of systems. I want to say here that we have, or the way we have designed the infrastructure makes the integration and interaction with other similar applications or services very easy. So here we have a powerful opportunity to create this system of systems solution for mariners and for ships, not only for the big ships, the ships that are under the SOLAS convention, but also for small ships using the mobile app. And finally, despite the name of the European Navigational Hazard Infrastructure, I would like to remark that we have no constraints or limitations in terms of the geographical scope. So we can support navigation safety in every single sea or ocean. And let me add something regarding that. We can also add location-specific management of the data. And moreover, in terms of scalability, which is very important when you are planning to support services, is that we are currently supporting a bit more than 30 different object types. We have several marine mammal species. We have floating objects like normal containers or reefer units, but we can easily extend the system with new object types. We have tested the ocean ecosystem with all the developments that we have been presenting today. But as I mentioned before, we can easily integrate more data sources, which is very important to increase the impact of the system, and to clarify that we are not limited to the developments that we are presenting. We are open to integrate more data sources, and that's all. I would like also to remark again that this the integration with Twitter systems is part of this of the future of ocean. And we took the decision to include a basic implementation of DS 124 because we believe that it could improve the impact in the future of the developments that we are being that we did in the project.
Thank you very much, Francesca. Very, very, very interesting. Harvey, you and your group have gone to extraordinary lengths to identify ways of detecting whales in near real time, which is so important, so that mariners have a better situational awareness and can make good decisions to avoid them. The video that we just saw highlights the use of hydrophones, AI satellite imagery, migration modeling. There's a huge contribution to environmental safety, but can you outline how a coastal state might start to consider implementing these tools to, say, further protect a PSSA, as should be so important here at EMSA?
That's fine, David, thanks. I think again, it will just be an outline because I have just a couple of minutes to do this. But in principle, the basic would be use what Ocean has delivered so far. There's a lot of development on either technology or principles or methodologies or paradigms. All that can be reused. Everything is documented really well, so that will be a very good start for everybody who wants to do anything with what we have been discussing here the whole day so far. If you talk about a practical outline, then it would be, first of all, make sure you know what you want to do. So do a bit of planning and make sure that you know what your aims are. So I assume as a state, if you or a region wants to make
a system which to protect whales or maybe discover containers, I think you need to make sure what technology do you have, what's the landscape from a ecological point of view, how about navigation. I think all these needs to be taken into account when you want to make a plan for where and how can I deploy technology. Also, just continuing what Francisco just explained, that whole central database system we have is like a gold mine. I would definitely just make sure reuse technology we have, either what we heard earlier, the models we have, which can predict, the hydrophones we talked about, the satellites we have, the app we are seeing many times today. And with the extensibility of that database system, I can also imagine that local nations or local regions want to have their own data source added to that. I think that is a 101 is too simple kind of calculation. That definitely should be taken into account. And then last but not least, in planning phase, there will definitely be get stakeholders involved, because without stakeholders, this is like a no-go situation. We can want whatever we want, but if nobody's going to support this, stakeholders, I mean, you don't get anything. So I'm looking at you, David, but I think there are many stakeholder movies created in the ocean projects just for this purpose. They're, I think, freely available just online. Go there, get them and use them would be number one in my opinion. But that's just assessment and planning. So then infrastructure development, deploy hydrophones. Just speaking on my own behalf, our hydrophone technology developed, including the software, including the buoy, everything is documented up to the maximum we could and would. Meaning, why did we use this cable? Why did we use that connector? How did we implement the machine learning software? How did we implement the infrastructure software? Everything is open source available, documented. So you just go there and do it yourself in a way you think is suitable, or you just go to a commercial organization, tell them, hey, Ocean has done this really great job. It's out there. Can you please build this for us? That's a possibility also. So I think, but I'm not talking for the group of Ludwig, but I think the satellite imagery setup can be reproduced, can be used. We have the migration models from the University of Azores, which can be either used or reproduced in the same manner for other areas and regions. So in that sense, it's all very easily applicable. And then we heard also about the app, can be utilized all over the world for free. As we speak, can be started right now. So no nation has a reason not to do this, in my opinion. And then data integration and decision support. If you have all these sensors and all these systems, just giving you lots of data into that global database, make sure you get to the customer, to the group we talked earlier there in the back here, Kongsberg. They have like a really nice system developed, which is able to make sure that all the alerts, all the messages are there to be used for navigators. I would say just contact them and get it on your ship as a nation. And if not, then make sure you get something similar yourself, because the navigators really need this to make sure they don't either crash themselves into a container or just kill whales, which is maybe even worse. And that would definitely include, in my opinion, the real-time alerts and the dynamic route recommendations. That would definitely be a bit of automation we can utilize to make sure we get real measures and not just human measures in place. I need to speak up. That's a pity. So then we have the most difficult thing. Maybe I'm looking at you also there, project officer, which is policy and regulations. Because if we have all this in place and everybody says yes, and everybody would say, yes, let's do it today. But if there is no mandate from government, if there's no mandate from the EU, it won't happen. So it would be, as an example, how do we update navigational charts? Some people still have paper charts. How do we utilize these? How do we get equipment mandatorily placed on ships? Or how do we include and exclude regions or speed limits mandatorily just because the law says it needs to be done like this? I think that is definitely what needs to be figured out. Not easy, but we need the EU and governments to work together and make sure that that is then possible, because we technology companies cannot do that just because we want it. And then last but not least, David, and then I'll just quit, is monitoring and evaluation. making sure it works is fine. Putting it there is fine. But then, of course, keeping it to work, make sure it reaches the goals, make sure you can tune it, make sure you get like the systems counting that indeed we have less collisions and less killed whales. That is very important. Just to outline for you.
Well, thank you for that brief outline. Very useful. Right. Well, one of the other things I really love about this project is there are so many things that we can bring forward, and if you want to use the term exploit, but that are going to be really useful in the future. And we've heard a lot about the technology. Jonathan quite rightly talked about the knowledge base that we've developed and is now in the public sector. But Georgia, you and your team at the NTUA have leveraged your extensive knowledge of shipping operations, risk assessment, and commercial understanding to help us identify how these ocean tools can be implemented and benefited in the long term. What does exploitation mean for the ocean solutions, including and beyond commercialization?
Thank you, David. So the truth is, for ocean exploitation goes beyond selling product to services. It also means using the result in policy and standards, building skills and capacity with the partners, within the partners, exactly, and sharing knowledge through training and dissemination, like training video, for example, with 10,000 views, which I know. Also mean helping authorities follow the rules, supporting coastal administration, and protecting maritime life. By lowering risks such as ship strikes on whales, for example, the project creates value that goes beyond commercial use and brings benefit and for the people and for the environment too. Each key exploitable result has its own pathway. Some are already in use, some are near exploitation, others need further development, depending on how mature it is and who can be benefit from it. But in the end of the day, the goal is the same, to bring lasting benefit to safe navigation. So that's all for me about this.
Thank you, Georgia. And also thanks for keeping that sweet and to the point, because I know your exploitation roadmap report is very extensive. So lots of things in my mind, but before we do that, are there any questions from London or from the people online? While you're thinking about that, Ali, I'd just like to recognize you for the fantastic work that you've done in this project. Your 7 training videos, which are absolutely free, that have been signed up to by over 60 organizations and institutes and have over 10,000 views on YouTube and the internet, are just a fantastic legacy of this project and a really good example of our exploitation going into the future. So thank you. Sir, the call is back to you.
Oh, thank you very much. Thank you, David. Thank you, panel. I want to... Oh, Ali. Go ahead. No sound, unfortunately.
Speak louder, Ali. You're in London. We're all the way here in Lisbon.
Okay, I think because I have control, thank you very much for the opportunity. The videos was done by the whole team efforts. It is a well-structured project, and we was following this strictly, to be honest. And I think we achieved by the videos a real impact where a lot of institutes and colleges are using it in their curriculum now. And with regarding whales, I really personally learned a lot, and I think we are put our foot in the right direction.
but I was speaking with one of the audience, unfortunately she left, and she is coming from the charter of the shipping. And she just mentioned one thing, maybe it's outside the ocean project scope, but if we are just highlighting this, and we are doing that with the International Whale Commission as well. So whales never come in the charter party clauses, and therefore ships might go off hire if they avoid whales in some circumstances. I'm not talking about all circumstances, certain areas, but within open sea, within ocean, we don't need to stress and force on only one stakeholders and leave the others. So that's one of the statement which was coming from the audience. So thank you very much, all of you. Enjoy Lisbon, and see you soon.
Thanks very much, Ali. Thank you. I just want to round off this panel with a really stupid question. So, Treya, it's to you. If I download the app to my phone, and I go down here and I see a whale and I click a report, it works. I don't have to pay anything. I have to register, and that's it. Is it that simple? Yes, it's that simple. So that goes for everybody who have any kind of interest in this. Download the app and start using it. It's that simple. There's no hoops to jump through. There are no permissions to get. There's nothing. Just go do it.
You know, there's not going to be anybody at coffee. They're all going to be down the river.
That's right. Yeah. Good. So we will round off this panel. What is now next is a coffee break. There, I hope that the Ocean Partners will be at the exhibition, so you can go and ask questions, and maybe you can even report a whale if you like. I would love to see that. I would love to see 200 whales in and around the river here. So let's go do that. Thank you very much to the panel. Thank you, David, for moderating. Just a housekeeping remark. Back by 15:40, we have two exciting things left. Three exciting things left, actually, which is me closing the ocean session. That's going to be really exciting. Then we are going to hear from the SafeNav project, which I'm looking very much forward to. And then Agnieszka, our project officer, has the honor and the duty, maybe even, of closing today. So don't evaporate. Keep up steam. Get some coffee, and kindly be back here by 15:40. Thank you very much.
So, kindly take a seat. And if there are people still outside, try to herd them in here. Or people upstairs. As you can see Kirsty arriving. Good. Just need to have everybody in place. So. This is my last time slot today, actually, and the title is to close the day. It's a 20-minute time slot, but I'm not gonna speak for 20 minutes. I think what we are agreeing is that we will skip the next coffee break, which is immediately after what I say. Then comes the SafeNav project presentation. And then, like we have been saying before, Agnieszka have promised to close the entire day. So we will do that, and we will do it in one succession. And that means that we will be giving back time a little bit to everybody to finish slightly sooner. And I've been told that that doesn't have any negative impact on anything. So when it comes to the ocean project, I really hope that today has served the purpose. I hope that those of you who have been listening either here in London, online, know a lot more about ocean. I hope that you have that whatever questions you might have had are reasonably answered, and we will make good on our promise from this morning. So if there are questions in the chat that has not been addressed and answered verbally today, we will get back to you, and you can still send us questions on this email address, and you can still obviously have a look at the website in case you want to dive deeper into something. You can also use the opportunity communicating with us, get in touch, and set up one-to-one Teams meetings or whatever you like. We are here, and we are available to answer questions and to keep on discussing. But all of that is much more than me talking. But there are really a few things I need to say. We have discussed that this is not the end of the day. I would very much like to thank the audience, everybody who have spent the day listening. As I said, I really hope it was worthwhile for you, and please come back and continue the dialogue. I would very much like to thank EMSA for having us here, for making this room available to us, this fantastic room available to us, I would say, and a really great tech team that is helping us along and making things work very smoothly. Thank you very much out there in the... And I think just equally much, Radina and the team deserves a lot of credit for accommodating all of this and our strange requests and all and sundry. So I think we should give some applause to EMSA as well. Agnieszka, thank you so much for being here. I know that I think we're lucky because it doesn't happen very often that we can entice project officers to come away from Brussels. But we are very pleased you're here. And I think you know from our exchanges that personal communication works so much better. And I'm really happy, and I'm happy you had the opportunity to listen to what we had to say. And I know that this would probably ease the rest of the way to conclude finally on the Ocean project that we are in good communication and good contact. So thank you very much. For me, it has been a pleasure. It has been, I would call it an easy working relationship. There have not been many deviations, and we have not had long discussions or arguments, but I think everything has been going very smoothly. So thank you very much for the way you are a PO. That has made my life very much easier. Then, obviously, what you have seen today here is the result of a teamwork, and what a team. You have met many of the members, and they are a terrific bunch of people. They are engaged, they're professional, they are dedicated. Some of them are even fun, and a few are good looking, but you know that. But it has been such a pleasure to be involved with Ocean and to be involved with all of you. And occasionally I feel like a fly on the back of a dog. I don't know who is controlling who or what is controlling what, but we have managed to get there. And I am humble and proud of our joint achievements here. So thank you to the team. You have done tremendously well, and I'm going to miss this in the future. Thank you. And that was all for me. So that means that I think I have mentioned everybody in the team.
Okay.
Yes.
But in that case, can I thank Eric for his grumpiness over the years, his putting up with us, and his fantastic leadership. I've been involved in about 6 of these EU projects, and by far this has had the most vision, the best leadership, and the clearest goals and objectives. And it's been fantastic. Thank you, Eric.
I think this means, I'm sorry if this is sandbagging the SafeNav project a little bit, but that means that we are ready. So whenever you are ready to present SafeNav, we are ready to listen. We are excited. I'm looking very much forward to hear this. Just for everybody's information, there have been good exchanges between Ocean and SafeNav over the last 3 years, and we are we are not even friendly competitors because we're not competitors. We're just friends who are working on something with the same objectives, different solutions, slightly different philosophy, but it's all about safety and navigation, and it's all about avoiding whale strikes. And so please, let's hear it. Thank you. Hello, everyone. My name is Jacek Maslak. I'm here to represent and kind of present the SafeNav project to you guys and speak a little bit about the collaboration that has been happening between the Ocean project and SafeNav, inspired by and a lot of the statistics that actually come out of this building, how many collisions and groundings there are per year, and then the underlying cause usually being pointed to is human error, unfortunately, and that connects with the safety tech in the maritime sector being quite ways behind some other sectors that we see when we think of automotive and all the new systems in cars like the ADAS system. So if you rent a new car these days, it will start braking for you. It might be annoying, but it's proven that these things work and make driving safer. Same in aviation. There's a TCAS system after it was introduced. Mid-air collisions are almost non-existent. So there's a lot of work to be done and a lot of opportunities in the maritime sector. Coming to a shared vision between what I think has been seen between what the Ocean Project is working on and their vision and the SafeNav project, essentially boiling down to enhancing safety at sea. and through and advanced data-driven decision support in the SafeNav's case, and a lot of other things in the Ocean project. But I think it's also important to mention the shared philosophy of the human in the loop. We see a lot of things that are driving towards full autonomy, etc. But I think working with experienced navigators and the people that do the day-to-day jobs out there, it's very clear that this is a direction that the industry is going towards. Today, we can already improve a lot by creating something for navigators by navigators, meaning enhancing what they can do and addressing the root cause with smart system. So essentially improving human performance, reducing cognitive load, and preventing errors under stress. In the case of the SafeNav project and its key results, it really boils down to a call compliant, because it needs to be able to, the system needs to be able to understand the rules of the road at sea. So it's a call compliant machine learning powered decision support system, acting as a sort of digital co-pilot, lookout, co-officer. All these terms would fit. So essentially, it's the real officer have to make judgments about good seamanship, and the system is trying to essentially be parallel to that. And in stressful situations, make a very, very educated and wise judgment call and give them a suggestion of what they should do in that situation, without them having to look at all the data streams that they get visually as a human being, and from all the systems having to do the computation, come to a judgment call themselves. The core technologies that come out of the project, it's a data fusion module, because we want to be able to ingest any data that a vessel has available. So if it has RGB cameras, IR cameras, but of course, all the other systems that you find on a bridge of a modern vessel. Then all that gets fed into a decision support system, and that's kind of the core, which in it has algorithms that assess the situation. So it's situational awareness, but then takes that and tries to make that judgment about good seamanship, being call compliant, and creating a path plan that minimizes the risk of collisions, but also keeps you on the path that you are trying to sail as a navigator. And all that is supported by what we call also observational database. And we'll talk a little bit more about that, because this is where I think our teams saw the most potential synergies. Collecting data. So if you think about all the potential near misses that happen out at sea, most of these are unknown. It's kind of a hidden statistic. An analogy could be mistakes that surgeons make, right? It's something that people don't really record, write down, because they're afraid. But if they did, and if there wasn't repercussions, it would make the whole industry a lot safer. So I think there's a great opportunity to collect data on near misses, on real behaviors of navigators, to learn from and to track those and to learn from them. And the key projects of the SafeNav projects was essentially a prototype that was validated initially in a full-scale bridge simulator in Genoa, then in Turku on an ASV vessel, so both on the vessel and then remotely controlled. You can see that photo in the middle. On top is Genoa, then in the middle that photo is in Turku, and then ultimately on a merchant vessel at sea, which is the last few photos. And we're also happy that we're working with DNV on an approval in principle, and we just received an acceptance with comments. So we're very proud of that and happy to work with DNV. And as before mentioned by Eric, in our case, we're also very proud to work with a fantastic group of partners in the consortium that have allowed us to achieve this. Synergies between the Ocean project and SafeNav. From the discussions that have been had, it seems that focusing on the data that is being collected might be the path of least resistance towards creating something of value. Essentially combining the data sets to have a richer data sets that provides more accurate insights. Both might have some some gaps and blind spots, which the other might fill, in order to be used in the whole industry to make systems that predict behavior better. And what has been discussed was a system of systems approach. Why that? Essentially, instead of trying to combine the two databases, they both are built differently, collect different things. So instead of trying to make a monolith out of that, the idea was to create a system that connects to both, and is able to ingest the data from both, and then, create a new combined system. And the benefits of this approach would be robustness and resilience, meaning that, the thought that went into creating both databases and making them work well and be robust persists. So we don't break any of that. There's resilience. If something breaks on one side, the other database is still there. It avoids any complex IP or ownership conflicts. When we think of research and development projects moving more into the commercial space, this would avoid that because the IP could remain in the consortiums that created these databases. And it would allow for different separate commercialization strategies to be explored by both sides while still creating this synergistic overarching database. And the second synergy we saw was in line with the fundamental kind of philosophy of the EC funded project is openness and interoperability. So again, going back to the shared value of bringing safety to the entire marine sector, I think that can be done through openness and interoperability. And this would allow for a network effect. So both systems increasing the value exponentially with the number of users and data contributors. Because if we look at a world where most vessels out there, whether merchant vessels or non-merchant vessels, having a system that collects data in a way that we all accept to be safe and appropriate, it would really, the number of data points would really allow for a lot of wonderful things to happen. Whether that's seeing every vessel as a real time weather and sea state prediction, but also about learning from the mistakes and from the correct seamanship of people that make the decisions on board the navigators. In terms of the Ocean project, I think being built around openness, with the open source nature, I think that's one foundational block of this. And with SafeNav, focusing on interoperability. So a lot of the things that we've been working on in the project is engaging with DNV, but also with a lot of system integrators to ensure that the systems we're building will be able to be used, whether that is by working and partnering up with some of the larger system producers that put navigational systems onto bridges of merchant ships, or other structures that are evolving, that are becoming a standard in the industry. Going forward, I think there are two interesting tracks to be explored. The first one is the R&D track. I think there's a lot of wonderful things that came out in terms of the research and development from both projects. And I think exploring if those can be combined to yield even greater value on the R&D front and future Joint Horizon project is one track. And the second track is any commercial or applied opportunities that we could explore between the Ocean project consortium and the SafeNav spin-off company. So one thing that we're fortunate to be able to do is to create a dedicated spin-off company for a focused number of the results from the SafeNav project. And that entity will be looking to engage with partners in the marine space, whether that's integrators or end users. And I think there is potential to also work with the Ocean project and other projects, and give them kind of a first step into the kind of a world and into the markets, whether that's pre-commercial pilots, kind of seeing if any commercial relationship that the SafeNav Limited spin-off will have with real customers will allow for integrating anything that comes out of the ocean projects, etc. That's it from my side. Thank you very much for this. Lastly, if obviously the SafeNav project website and all the R&D will continue, if there's any interest in the commercial spin-off from anybody here, that spin-off has been seeing great momentum. There are end users who provided initial angel funding, which is fantastic and wonderful. There's active talks with institutional investors in the marine space, which aren't many, but there are more and more. I think institutions are seeing that there is a lack in technological improvement. Also engagements with the primes and system integrators, as I mentioned. So yeah, please reach out if there's any interest talking about that. Thank you very much. Very much. Thank you. Thank you. As you can see, there's opportunity for going forward. And I guess that this was a very kind invite from the SafeNav project, opening a number of doors. And I guess that on the side of the Ocean project, we will have a look at that. But it is, and I need to say that the way the Ocean Consortium is set up, it is very much up to the individual partners to signal their interest. And I think that maybe this is the way we should begin on the ocean side of this, that let me know sooner rather than later. Let me know if any of you have an idea, and I would be happy to act as the go-between between the ocean partners and the SafeNav project. But it would be a waste if we don't try to exploit that we have so many overlaps. And so I'm hopeful and maybe even confident that some of the ocean partners would very much like to reach out and have a deeper conversation around this. The only promise I can make right now is that I will try to make it happen. So thank you very much. Thank you. And that takes us to the end of the day, Agnieszka. This is you. Wow.
Well, it's been really a long and interesting day. First of all, I wanted to thank you very, very much, Eric, for cooperation over those last 2 years. I took over the project just before the first review. And it was very interesting to see how developments are going, how cooperation with SafeNav is proceeding. So from this perspective, yes. How to summarize such a day? Once again, I'm very happy that this meeting took place here, because all the panels, all the discussions, presentations are showing that the results of research, it's not good if it's just locked somewhere in a drawer. It needs to be implemented. It needs to, if it's serving a bigger purpose, like the results of Ocean and SafeNav are, in my to my understanding, then it needs just a bit of encouragement to the legislative, to the regulatory bodies, because it's showing the practical and technological developments, how they can contribute to safer navigation and better future in Europe. Yeah, I was thinking whether to go through the whole agenda again, but I took some notes which I think may be interesting for you. EMSA, I've noticed they noticed a lot of similarities in the activities which they are doing, and Ocean and also SafeNav are doing. It's interesting. They considered the results as very interesting and aligned with the timeline of the IMO and what EMSA is currently doing, which is a very good sign. From the first panel on the situational awareness, I underlined several experts and saying we learn from experience. We need experience to be our basis. So yeah, this is something which stick to my mind. I've noticed that also there were several requests for providing feedback to what is still being done within the project. So you have the 7 videos on training. You have the app, the software. The project is still looking for your feedback. The app on reporting of navigational hazards, that is something very easy to use, as Eric explained, but people need to know that it exists. So I'm glad that you announced this app here, because that gives a chance for a take-up really. I'm very glad also I was very glad to see this session on implementation and exploitation. Those are very important aspects of all of the projects. We want the results to be taken up, used in practice. And I'm very glad that we also managed to get SafeNav here, as we are always from the Commission side supporting this synergies and cooperation between projects. So thank you very much also for coming. Yeah, thank you all for your time, for sharing your knowledge, for asking brilliant questions. And I wish you all a very nice weekend then.